for the morning sessions of the 5th day. Our theme for these sessions, for session 7, is microscopy and compositional study. My name is Mudit, Trivedi, and I think we can all start again by thanking Alok, IIT Gandhinagar, IIT Madras, and especially the Tamil Nadu State Department of Archaeology, who have made us so welcome here. And it is my pleasure to introduce as today's first speaker, someone who has trained generations of ceramicists in India, Professor K. Krishnan, whose topic, the topic of whose paper is Scientific Analysis of Archaeological Ceramics.
Nothing is coming. Very good. And where is the pointer? Good morning, everybody. Actually, the title is very broad. I'm not specifying, because when I was asked to give this abstract, I was not sure what I should be presenting here. So I gave a very broad title. I thought that Alok would reject it, but unfortunately he accepted it, so I'm going to make a presentation based on some of my studies. Are you able to hear me? Yeah, this. So it's a summary of most of the works that I have done in the past, and also how I developed a methodology for understanding the questions. Basically, what you are seeing here is the one that is in the middle. This is a thin section of a ceramic piece, and the method that we are following is the same kind of method which is used by geologists. Now, at the outset, let me thank Archaeological Survey of India, Department of Scientific Research, British Museum, University of Wisconsin-Madison, then colleagues and students from the Maharaja Sajara University of Baroda, Indian Institute of Technology, Madras, Chennai, who gave me this opportunity to speak here, and the Tamil Nadu State Department of Archaeology, also Dr. Alok Kanungo, the organizer of this particular conference. Now, I have just mentioned the names of the institutions because there are many individuals who have been helping me in my studies, so it is impossible to give the names of each and everyone, that is why. Now, this is mainly meant for the students who are sitting at the back side. The kind of ceramic analysis, there are 3 types that we do. One is the archaeological analysis, where you have categorization and classification, which leads to understanding cultural contacts and the movement of the population, and also the spread of technology. When I say technology, it doesn't mean that manufacturing process, it is something beyond that. There is a necessity for a technology for a society, and also the society outside of it. And also there is an element of cognition that is involved in it. So all those things would come in that. We often see people writing manufacturing process as technology, which needs to be a little modified now. Then we have archaeological studies to understand the production techniques. We have been seeing one example outside now. So this would also encourage you to understand the distribution patterns of different ceramics, and also the meaning of attributes, which is very complex. That is, some of the designs, what do they mean, and why are they created? Does it mean the same thing to the person who is looking at it, and also does it mean differently for the person who created it? Then the scientific analysis, which is primarily characterization studies. So the difference here is that the first one is looking at the surface features, the macroscopic features, and the second one is trying to understand it in a workshop, potter's workshop, and the third one is looking at the compositional part. And there are 2 ways of looking at it, one from the mineralogical point of view, using the microstructural analysis, And the second one is from the chemical point of view by looking at the chemical composition. Now, why do we use this kind of studies? It's basically to understand the manufacturing process and technology. So I'm giving it differently. And then appreciate the pyrotechnological issues. It is very difficult to understand how these people created such kind of environment within a kiln, and also how did they carry out this baking exercise, what kind of precautions they took, and what was a kind of, or what was a character of the particular ceramic that was kept within the kiln, and how does it come out, all those things. Then technological continuity, that is something which is very interesting actually. If you look at the microstructure of the ceramics, can you see the technological continuity? Here I will be demonstrating it a little bit. And then cross-cultural links, that is between two settlements or within a settlement or settlements which are far away. And the technological adaptations taken by within various regions. If you look at the Indus Valley ceramics, you find an overall technology or overall method of production, and also you have certain regional production centers, certain regional elements within it, and that keeps varying. So the common scientific methods which are used in South Asia, it includes thin section analysis, that is, I will define what is thin section in the next slide, where you are trying to speak about provenance and texture. I must say that this thin section analysis, the first work in this one was initiated by a British geologist in 1886. He was a sedimentologist, and he started looking at the ceramic thin section the same way he looked at the sedimentary rock, which became, at a later stage, a very critical thing, because people started saying that you are looking at it like a stone piece, and you are not trying to see the man behind the artifact, or the hand of the person behind the artifact, or the mind of the person behind that artifact. So it has undergone a lot of changes, and it was not a very popular work or popular method in the early 20th century, but later in 1959, it became very popular when David Peacock, one of those pioneering workers in this field, he managed to get some ceramic studies done, and the ceramics were coming from, or the site was located in an area which was surrounded by contrasting geological formations. So as a result of which he could see different minerals from different formations, and that was giving him some kind of, it helped him to identify the provenance. So there it became successful. But when it becomes, when you are working in an area which is extremely of a, very disturbed alluvial terrain, it becomes very difficult to work with that. So therefore, we look at the texture, that is, looking at the different parameters like grain size, grain shape, and percentage of non-plastic inclusions, and you try to work out what exactly is a textural definition of a ceramic specimen, and compare that textural definition with the textural definitions of other ceramics. X-ray diffraction technique, basically, it gives you the composition, but it does not give you the visual control. Whereas when you are looking at a thin section, you can see the grains there, and you know what exactly are the ones. But whereas in XRD, it becomes very difficult to understand the texture. It gives you a composition. These two studies are complementary to each other, and whatever the kind of thin section results that you are getting, that can be confirmed with the X-ray diffraction method. Then chemical analysis method, wet chemical analysis. I stick to wet chemical analysis because, of course, it is time consuming, but the kind of results that you are getting is quite reliable. Whereas in terms of instrumental methods, there are certain issues. Sometimes, you do not know which mineral is interfering what. And in wet chemical methods, you can remove those elements which are interfering radicals, and you can keep the one which you are looking for. So wet chemical analysis, I prefer doing wet chemical analysis, maybe because I did not have much facilities for instrumental analysis and all. I have only one atomic absorption spectrophotometer. Then we have EDX, that is energy dispersive X-ray analysis, ICPMS, inductively coupled plasma mass spectroscopy, then neutron activation, and atomic absorption spectroscope. Then there are also some other methods like scanning electron microscopy, differential thermal analysis and thermogravimetric analysis. These are all some of those popular methods which are used in South Asian ceramics. The targets that we have been able to achieve throughout this study, that is, we were able to differentiate between the paste recipes of different periods. And we were able to say about the provenance in general, that means overall, not the exact locality. We could not pinpoint the locality because thin section studies have its own limitations. And also you need to do a clay mapping because you need to understand if you are taking a lacustrine deposit and if you start sampling every 10-meter interval, which I have had an experience of doing it, and I found there are minor variations within the clay composition because it happens also. It's a natural process because when it gets waterlogged and there is some kind of sorting takes place there, and as a result of which some of the minerals get shifted to some other point. Then baking temperature determinations of specific ceramic types, that is by looking at the transformations that take place in the minerals, that is one. Second thing, you can also do it with porosity studies, understanding the porosity, or even if you use the porositometer, you can do it. Then you can see if you have patience and time and all those things, and if you can prepare clay tablets and heat them at different temperatures and understand their microstructure and compare it with this, you will be able to somehow work out the baking temperature. Techniques of manufacturing, that is. The nature of handicraft and industrial ceramic traditions, which I will come to it later. Now, still there are a few more areas to be understood, those people who are working with this scientific analysis. That is, levels of transformations within the society. How does it happen? Because can this particular study give you any kind of clue towards working towards this particular thing? Second one is that levels of standardization of craft and technology. That to a great extent we can do it. Then organization of production and levels of society. Of course, if you take a kind of multi, that disciplinary approach, you can do that. Now, this is what a thin section looks like. That is, you have, it is a transparent section that is the one which is in the middle, and this one. This is a polished section of a piece of ceramic, and it is 20 to 30 microns, let us say 30 microns. Because that is a thin section of, that is the thickness of the thin section. So we have to keep it at 30 microns because the optical properties of those grains whose size is lesser than 30 microns are not clearly visible when you are looking at it. So you can only say that clearly identify those minerals whose size is above 30 microns. So whenever I am using the term grain, it means that grain has a size either 30 microns or above 30 microns. So the first exercise was to see how does it get translated, the potter's process get translated into a ceramic thin section. So these are all some of those different kind of stages of production of ceramics that you can see. This is, the potter is collecting the clay. This is from Sri Lanka. This is at a deposit in Sri Lanka, and he is collecting the clay. And this is North Gujarat, and this one is again in North Gujarat, and this is also in North Gujarat. And this person is Sri Lankan, and he is also doing, this is also in Sri Lanka, the foot kneading. And this is a potter from Mathura, but he lives in Baroda. My first study, I did it with him. And this one is the pot making in Sri Lanka. You can see the general balancing and all those things. And second one, the piece is taken out, and you can see the middle of it, it is empty, it is a hole. And now he is using the dabber and anvil to enlarge it and also give it a form. And these are all the different types of dabbers. And some of them have grooves, some of them do not have grooves. And here I want to say something, that is, we are speaking about paddle mark pottery. And we need to define what exactly is paddle mark, because the paddle mark, is it a design or is it a part of the technique of production? That is something which we need to see, because we are considering it as a design, But if it becomes a design, if there is a pattern in which it is done, otherwise it becomes just a kind of a pot enlarging technique. And this particular potter, he does it with a blank paddle, and first he does it with the one with a groove, so that the moisture and all those things do not destroy the shape of the vessel. Then he does it with a blank one, he rubs it with a blank one. Then if it is necessary to give a design, then he uses the paddle and gives the design. And the lower ones are basically pigment preparations and application on the vessel. Now, these are all some of those different types of kilns that I have encountered in my, some of them I am showing it, and this is a very interesting kind of kiln. This is a kiln from Sri Lanka, which is used only by the Tamil potters. It's a large one. You can accommodate more than 1,000 small vessels, and if they are fairly of the medium size, what I mean by medium size is the size of the pot which you saw there outside, something around 400 vessels can be accommodated in that. So there are different types of firing that they are practicing, that is oxidizing environment as well as reducing environment. And these give some particular kind of color and quality to that particular vessel. Now, this is one of those prerequisites for thin section analysis actually. Basically what you are seeing here is that this is a black clay and this is a red clay and this is a prepared clay. They are mixed it. And here this is the base of the vessel and the rim of the vessel. The major assumption that we have when we are doing this thin section analysis is that the distribution of the minerals within the clay paste is homogeneous, and the one which is on the top and the one which is at the bottom, they have the same kind of composition. Here if you look at it, what you can see is that it is less than 15% is the frequency of the grains within this. Grains means those who are above 30 microns, and they are sub-rounded. And when it goes to the red clay, you have 45% of the grains in this one, and the grains are angular to subangular. So you have a dominant one with sub-rounded one, you have a dominant with angular and subangular one. And then the prepared clay has 25% overall grain, and angular to subangular, the dominant one, and the sub-rounded one is also there. Then when you look at the base, same kind of composition gets repeated, and even the mineralogy is the same. So basically, this is done from several workshops, and I have a fairly good collection of these reference samples there in Baroda. Then through this kind of ethnographic exercise, what I found is that there are 4 types of production. I make it into 4 types. One is household production, where you have the part-time specialization or occupation, and the degree of standardization is fairly low there. Second one is a non-centralized production, where it is part-time specialization only and or occupation, moderate degree of standardization. Then there is a centralized production, then incipient to full-time specialization, and then high degree of standardization. That is how I found. Then administered production, full-time specialization, high degree of standardization. So this is actually from the survey of maybe around 20 ethnographic workshops and interactions with them, and also thin section analysis of somewhere around 300, 400 thin sections. Now, based on that, you can make certain kind of assumptions. There are possibilities. These are all some of those possibilities. You may have multiple geological sources, or you may even have a single geological source, where multiple techniques are used. And if you combine it with the archaeological information, what kind of informations or inferences, tentative inferences that you can draw, whether it is a household production or part-time specialization occupation, and then low degree of standardization. Then, does a society, is it an egalitarian or ethnically differentiated society? And the movement of the goods are within the society itself, internal, and if so, external also, if there are any possibilities of having external ones. Second one is the non-centralized production, which is a part-time specialization or occupation, moderate degree of standardization, ranked societies, chiefdoms and all those things. It's mostly internal movement. Single geological source and standardized techniques, which I am getting it here, where available archaeological information, that is centralized production, incipient to full-time specialization or high degree of standardization, rank to state-level society, internal and external, administered production, full-time specialization, high degree of standardization, state level, it is internal and external. So basically trying to, these assumptions are primarily to help me to make some kind of interpretations which the archaeologists can understand from the ceramic thin section studies. Now this particular slide appeared, this was presented by Professor Canoyer here. I am going to show you some of those samples which I have studied from archaeological context. And the first one that I had certain samples from Harappa, very kindly given by Dr. Canoyer, and the Ravi phase materials. And if you see here, the first one on the left side, that is a globular jar, 5 to 8% is the amount of grains in that. And you can see here, the magnification is given here. And the second one is again a globular jar of buff variety. And the third one is again a globular jar, but it has less than 15%. So there is a variation in the texture. Now what does it mean is something which needs to be investigated into. And at the bottom there is a cooking pot, less than 15%. And then you have a polychrome bowl which has a grog on which Mark and we have some, we have been debating on it. There is a grog means it is a broken potsherd or a powder potsherd. And you have the body of a globular jar here, the last one. So there which has, its percentage is less than 10%. So what you see here is that the percentage of non-plastic inclusions within it, this is one of those main ingredient, this is one of those most important properties that give the quality and strength to this particular ceramic type. And if you look at the mineralogy of the Ravi phase, I must say that we are using, and depending on feldspar, quartz, mica variations, the percentage of how the percentage keeps varying. That is what I am trying to look at it. And there are different variations here, one here, then the other one you can see here. So there are some different variations are there. These different variations are taken into consideration for establishing the provenance. Now this comes to the texture of the Ravi phase ceramics. You have a globular jar here, then you have bowl here, then you have a cooking pot here. So the texture, how does it vary? You have taken silt, very fine sand, medium sand, and coarse sand. These are all the ones. And in some of the cases, the silt percentage is very high, and in some cases, the medium sand percentage is very high, and coarse sand percentage is very high. So like that, it varies. So there is some kind of deliberate attempt from the potter's side to make the paste in the way it is required for forming the vessel. Now it comes to the early Harappan ceramics of Harappa, and you have a globular jar, 5%, that is overall this here, and this is 10% here, that is the frequency of distribution of non-plastic inclusions, whereas it comes to this one is globular jar, again 5%, and here this is globular jar 10%, globular jar 10%, globular jar 10%. So you have a variation from 5 to 10%, more or less a consistency is maintained. And the mineralogy of early Harappan, this is, now you can see mixing of two clays. After some time I will say that it is two localities, okay? And then addition of sand, that is what is, which is significant here. Then when it comes to texture of early Harappan ceramics, you have unimodal, semi-bimodal, and bimodal. So a large number of samples were analyzed, around 172 samples were analyzed. Then I am moving from there to another site, which is Birana, that is located in Haryana. And that excavator had given this kind of sequence, that is, he had divided it into two periods. Period 1, A and B, that is Hakraware and early Harappan. 2A, 2B, that is early mature and mature Harappan. Then around 120 samples of the early Hakraware and early Harappan were analyzed. And These belong to some dwelling pits, and they fall under the category of early Harappan, and the samples of Hakra phase was proportionately higher in the set of samples given to me for analysis. Now, these are all some of those things: mud applique ware, varieties of red ware, then chocolate slipped ware, bichrome ware, tan slipped ware, varieties of grey ware. These are all the kind of archaeological classifications of the ceramics which I analyzed. And if you look at it, there are 10 groups in this one, and 10 to 15%, 10 to 15%, 5%, 5%, 5 to 10%, 10 to 15%. So if you look at this, the grain size distribution pattern, the frequency of grains within this Birana ceramic thin sections, and if you try to compare it with that, the ones from Harappa, of course it is quite far away, there is a similarity in the paste recipe of these people, which means that there may have been kind of technological spread or something of that sort, one can say about it. This is a mineralogy of the ceramics, and you can see the 10 groups and the kind of minerals that are used: quartz, feldspar, mica, calcite. There are certain rock fragments, augite, another mineral, then grog, which is again crushed pottery piece, mica schist, argillaceous inclusions, and hornblende. When it comes to the texture, this is a texture. You have some of the cases you can see unimodal, mostly unimodal, and also there are some bimodal cases here. I'm going to Harappan ceramics from Harappa now. Then this is the first one. If you see, this is a Dishon stand. 15 to 20% is the frequency of grains in that one, and in this Dishon stand there is 10% plus. 10% plus means it is something around 12 actually, and then this one has 10 to 15%, and the modern clay is 20 to 25. So the interesting part here is that the Harappan ceramic thin section, the mineralogy, that agrees with the modern pottery, which were, of course, these were made in the site through experimental archaeological work. So more or less there is some, the same source is used here. And when it comes to this is the distribution of the grains here, the mineralogy, and you can see there are, some of them have only quartz and some have quartz and feldspar. That variation is, so this is just feldspar and this is feldspar quartz, and then the other one is mica. This is a texture. You have bimodal, clearly two peaks, unimodal, clearly two peaks bimodal, and this is also semi-bimodal, the first one. When you go to symmetry H, you have, if you look at this is 10 to 15%, and this is 15 to 20%, this is globular jar, and again globular pot, 15 to 20%, and this is a cooking vessel, 20 to 25%. That is a variation in the frequency of the grains in this one. And this is a mineralogy, and cooking pot has a very different kind of mineralogy here, because it has more or less feldspar and quartz quantities somewhat equal, you can say. And then when it comes to the texture of the ceramics, the cooking pots have definitely, it has a very prominent bimodal distribution of grains, and also the globular jar has one of the second one. It also has a bimodal distribution of grains. And then here I am coming to playing with the data. This is some select samples. What I did is that out of these 172 samples, they were classified into different groups, petrofabric groups, that is how I call it. And then some of the samples which were taken for point counting for the first set of analysis, they were plotted here. And there are certain localities, that source is here, this is a source, this has a different source. And then within the localities itself, there are certain variations taking place. Now, to know whether these are from the same source but from different localities, or if you add more points to it, or if you add more number of samples to it, does it become one cluster? That is what a small experiment that was conducted. But still you can see when I added more samples, because afterwards what I did is that I started running the samples once again, and more number of samples were selected and they were point counted, and is coming. So there is definitely 2 or 3 localities and 2 major sources. That this is one, this is the second one, this is the third one, it's the fourth one. So like that, it is 4 localities you can see here. And when it comes to, this is the textural analysis of samples from Birana, and you can see there are 3 categories, that is silt, very fine sand, and fine sand and medium sand and coarse sand, like that you have. And you can see there are 3 clusters also. And when it comes to the mineralogy of it was a bit difficult because the geology of that area does not allow you to really permit you to understand or pick up the source. More or less same kind of minerals were there. So what we did is that we looked at the susceptibility of these minerals to weathering. And based on that, it was possible. Of course, we were getting this kind of, I was getting this kind of 3 clusters, but then based on the susceptibility of those minerals, it was more or less, it was possible to establish that there are 3 different localities or sources. Localities, I would say. Then some of the observations that this is the compositional similarities in general refer to its source within the alluvium, and variations that minor indicate different localities within the alluvium. So what I say is that more or less they were from the same source but different localities. Then a slow evolution of paste preparation, percentage of grains and its distribution character you can see. Then forms and phases, Ravi phase, you have unimodal and semi-bimodal. That is a kind of distribution of grains there, whereas it comes to early Harappan, you have unimodal, semi-bimodal, and bimodal, so there's a bit of technological advancement. Then the bowls of Ravi phase, you have unimodal and bimodal. Dishon stand is primarily bimodal. Cooking vessels from Ravi phase, unimodal, calcite and bioclast. These are all the minerals which has a coefficient of expansion which is very close to that of the clay. I'm only halfway through. Can you give me some more? Where is Alok? Okay. So here I want to say is that this is the way that we can differentiate that there are certain kind of method, there are certain kind of variations in the clay paste preparation method. Then in Ravi phase, you have multiple source or localities. 4 localities I've been able to see. Then mixing of 2 sources is also there. Then early Harappan phase also you have mixing of 2 clays, that is from 2 sources or 2 localities, and also addition of sand. Then there is a difference between the Ravi phase method and the paste recipe method and this method. Then when it comes to Harappan phase, 2 clay sources, which collected from 2 localities probably. Cemetery has 3 sources or 3 localities. Then cooking pots from Ravi phase and cemeteries have different provenance. And mineralogy of the Harappan thin sections are similar to that of the modern clay from Harappa. This is one of the things that we observed. Then a tentative summary, that is multiple techniques were used, controlled exploitation of resources, multiple ways of resource mobilization or management, that is composition of ingredients, then raw material selection and processing for specific categories, continuous use of local resources. These are all some of those inferences that can be used with archaeological information, and then you can bring out certain kind of perspectives. Now I'm just, since this was added yesterday, I didn't want to make a presentation of this, but then there has been several, people were showing about this research slipware. So this is a research slipware which is a glazed research slipware. This is published. There are 2 articles if you read. That is one in Archaeometry, the other one is Walking with the Unicorn. Unicorn is here. So if you read, that is a volume which is done for Professor Mark Kenner, Walking with the Unicorn. So there is an article in that one. So it's a summary of that, these 2 articles. This particular research slipware, actually there were a lot of debates on this, and some people thought that it is it's a glazed one. So we were trying to understand if it is a glazed one. If it is a glazed one, that means that technology of glazing goes back to somewhere around 2500 BC, which is very, very, very exciting. But then, secondly, glazing is a chemical thing. You have to have a certain specific kind of chemicals to be used, and it's a Based on that only you can say it is a glazing. So we tried to look at it and some of those things. And here you can see the scanning electron micrographic image. And this is the black line that you are seeing there, and this is the gray one. The gray one is above the black one, and you have large number of iron oxide particles here. That is what is giving it a black color. And there is evidence of sintering. Sintering is actually a crystal growth. That is, two crystals come together and they melt and they become one. So that is in the layman's language I can put it. So it is sintering that is giving this kind of effect for that. So I would prefer to call it as a sintered reserve slipware. And this we did it, and then we also did the chemical composition of it. 5 minutes, huh? Chemical composition, and found that and tried to plot it. And here, interestingly, two different clusters were emerging, which means this was the production centers. There may have been more than one production center. That is what the kind of conclusion that we had. So to examine that, it was a torturous job to go through around 240 thin sections of samples collected from two of the sites which were excavated by the Maharaja Sajarao University of Baroda. And those sites are, one is, this is Bagasra, the other one is Shikarpur. Both the sites have yielded large number of this sintered reserve slipware, large number in the sense in hundreds, okay, not in thousands. So we have different varieties, that black and gray, then red and white, red and black, brown and cream, and purple and cream. So it was also, we thin sectioned it, and also this is one of those things which we get it from the Anartha tradition, one of the ceramic that reserve slipware types that we got it from there, and try to see if there is any kind of connection between this and this. So here what you are seeing is that it is well sorted, parallelly oriented, and whereas here it is moderately well sorted, and then the third one is sorting, high variance is there, and here you have, this is coarse redware group, and this is another redware. So you have these three varieties coming here, and then we try to plot it on the graph. This is basically trying to see if there is any difference in provenance and all, because overall provenance was understood by calculating the percentage of different types of minerals within that. And then the major inferences are, we have four major petrofabric groups suggesting four raw material sources or localities. Raw materials were collected from four different localities, and both the sites indicate the presence of all the groups. So now it becomes, because if you assume, we assume that each site will have, or the petrofabrics that we are analyzing, that will fall to site-wise falling. It was not happening there. So the majority of the ones from the Shikarpur were fairly coarser in nature. And the concluding remarks are, there are centralized production centers in Kutch region. It was matching with the mineralogy of the Kutch region, and then the monopoly of this technology is from Kutch, because Kutch is, the sites in Kutch, they yield this kind of ceramics to a high percentage. Then it is a specialist potter. It is a specialist potter, not a specialized potting workshop. Potter is a specialist, I think. So in case if you want to debate on social elites and all those things, probably this is one of those kind of ceramics that was made for social elites. I know that it can create a lot of controversy and all. So its production enhanced the economy of Kutch, and this richness of the clay in Kutch region was exploited by the craftsmen. Then explorative mentalities of the society and familiarity with a variety of raw materials and technology of the Harappans, that needs to be appreciated. And this can probably give an idea about the Harappan land use pattern for industrial purposes. Then Morbi is still the key center of production of ceramics and many varieties of modern ceramics, because they are using the same kind of clay. Now, what are the future prospects of this? That is residue analysis. Kalyan Chakravarti is doing it a lot. That is one of those future prospects. Then you can also understand the levels of standardization, craft specialization, and also probably the organizational aspect of production and distribution once we carry out this kind of varieties of techniques have to be used. Then you have to, you can look at or appreciate the social and economic stratification of the society. Then the role of superstructure in promoting craft specialization. And all these could add very important components to understanding the process of urbanization. Thank you very much. And thank you for giving me some discussion.
Our next speaker is Dr. Sidharth Shankar Rai, who is an assistant professor at the Department of History, Babasaheb Bhimrao Ambedkar University, Lucknow. And the topic of his paper is some aspects of NBPW manufacturing technologies, where he will be bringing together insights from his exciting and pioneering work on this extremely important topic.
Thank you. Thank you very much, Dr. Mudit. Good morning. Good morning to all of you. I am Dr. Sidharth Shankar Rai from Babasaheb Bhimrao Ambedkar University, Lucknow, and I am going to present my paper on some aspects of NBPW manufacturing technologies. First of all, I would like to express my gratitude to all my teachers, excavators of archaeological site of Kaushambi, and from where my samples are collected, and to the G.R. Sharma Memorial Museum, University of Allahabad, for providing me samples for this study. And of course, Nanophosphor Application Center and LIFS Lab of the University of Allahabad. And some samples were characterized at IIT Gandhinagar and PRL. So I'm also thankful to both those institutes. And especially, I want to thank Dr. Alok Kanungo, who arranged analytical facilities for me, which were inaccessible without his guidance and support, and of course, for providing me an opportunity to present my work here in this esteemed international conference. And I'm also thankful to IIT Madras, Tamil Nadu State Archaeology Department, Indira Gandhi Rashtriya Manav Sangrahalaya, for inviting me here in this conference. Thank you. As we all know that northern black polished ware is one of the earliest glazed ware of the Indian subcontinent. Of course, after reserved slipware, the radiometric dates push back its antiquity to 8th century BC. But it is generally associated with the archaeological site of urban characters developed during the Buddhist period around 6th century BC onwards. This is, however, very numismatic pottery. And NBPW was a specialized craft in ancient India. And the better way to study this pottery is the combination of different techniques instead of a single techniques. The firing of ceramics altered the structure of clay minerals such that their original mineral structure is destroyed and difficult to or impossible to determine any minerals. So we have used several techniques like semi-medius XRD, and for provenance of this pottery we have used a laser-induced background spectroscopy LIFS, and of course we confirmed this result with ICP-MS. So here I'm going to shed some lights on manufacturing technology of this pottery, especially the surface gloss and firing process using SEM and XRD techniques. And I'll try to correlate local production of this pottery at the site of Kaushambi using LIFS and ICP-MS. Here, this is the image of a slip of NBPW. This is the high-resolution image taken at different scale to determine information about the mineral present at the surface and core of the pottery. High resolution same image at ascending magnification are taken in order to understand microstructure of the surface, slip, and core. Here we can see this is a same micrograph at very small scale, 500x, and we gradually increased its resolution to 1000x, and then 2000. Here it is important that we can see this micrograph is taken at 4000x, and this is the outer slip, glossy, and this is the core. Here at 8000x, it is quite visible. These images are taken at different magnification and show compactness of outer surface. Here we can see that outer surface is very compact, while inner core is a little bit loose in comparison to outer surface. Here, same images in ascending magnification order show that outer surface of slip is amazingly smooth. This is. But there is no evidence of any kind of slip. Outer surface containing glossy surface is entirely fused with the core of pottery. This. I'll back to these images after discussing mineral composition. It indicates that some kind of solution might have been used before firing, not after firing. If you use something before firing, that it may be fused with core. So before firing of the pottery and during firing process, it fused with the surface of the pottery. That is why we are not getting any kind of evidence of slip here in same images. Here we can see this and this image are taken here. This is the development of some kind of minerals. I'll back to this image after discussing XRD result. And the phase purity of the NBP samples were investigated by XRD here. And as a result, 5 major phases were obtained. The XRD data of brick sample, we have taken actually 7 samples, in which 1 were brick and 6 were pottery sample. And this one is brick sample. Bricks were baked at low temperature and pottery were baked at high temperature. So there we can see differences in mineral composition and quantitative analysis of these minerals. The phase purity of the NBP sample investigated by XRD, and as a result, 5 major phases were obtained. The XRD data of brick sample shows similar phases of clay composition, but in a little bit different quantity. The major phases presented in NBP sample were kaolinite, biotite, albite, mullite, and quartz. Some kind of montmorillonite, gibbsite, illite, and some intermediary phases of these minerals were also identified. Here, after the analysis of brick sample and XRD sample, we identified kaolinite mullite transformation. Kaolinite were the major mineral in our brick sample, while in NBPW, mullite was a major mineral. And this is a kaolinite mullite transformation. Kaolinite is a mineral which change into metakaolin at 550 degrees centigrade, and this is a reversible reaction. This H2O is not here, but this is a reversible reaction. If metakaolin come in the contact of H2O, it can retransform into kaolinite. But if metakaolin heat at 1000 degrees centigrade, it can change to mullite and quartz. So if we get in brick sample kaolinite 60% and mullite 7.4%, means at low temperature or in brick sample which were baked at low temperature, both minerals were present, kaolinite and mullite, but kaolinite percentage is more. But here in NBPW, we see that kaolinite is less and mullite is more, and also we see increased quantity of quartz. And this is confirmed with XRD data and also quantitative analysis of XRD data. We have quantitative analysis through Ritvik method, and quartz were analyzed with a small software, RockJock. Here, in this NBP sample, we can see kaolinite. This is a crystal of kaolin. We can see this is intermediary phase metakaolin, which grow into quartz, and at increased temperature, some overgrowth of quartz is seen in NBPW. Here we can see mullite crystal, and beneath the layer of these mullite crystals, we see overgrowthing of quartz. And this one is mullite. This one is secondary mullite. And here, beneath the secondary mullite, we can see primary mullite. First of all, in kaolinite mullite transformation, first of all, kaolinite change into primary mullite, and then it change into needle-like structure of secondary mullite, and it originate at around 1200 degrees centigrade. And if 1200 degrees centigrade we maintain this temperature, entire primary mullite change into secondary mullite. This is the black outer layer just below this, and this is montmorillonite. This mineral is, this is quartz, and this is kaolinite. Now, this is elemental map of surface of NBPW. Here we have mapped eight phases, which shed some light on surface and nature of outer surface of this pottery. So in order to understand elemental distribution over surface of the pottery, a fresh scratch were created on this surface, and then analyzed with energy dispersive spectroscope, EDS facility attached with our SEM. In this elemental mapping, we can see titanium. Titanium is equally distributed at the surface and in the little bit core. So titanium is, because equally distributed, we can consider that titanium was in clay and titanium was in slip also. So it may not be considered as a deciding element for any kind of glaze or any kind of slip. Here, variation in silica, oxygen, selenium, and aluminium. These four elements show good variation. Selenium is a non-metal element of the sulfur group and is frequently found in soil. And silica and aluminium are the main constituent of clay. Silica is where semi-metallic, and aluminium is a metallic element. So both are present in the outer surface and in the core of pottery, but not in pure core, not in the mid, not in the pure core of the pottery. So potassium and iron both are present homogeneously at the outer surface, outer thin layer, and in the core. So our X-ray microanalysis of core and edge show that in all cases, potassium peak was higher than iron peak. And silica and aluminum along with potassium and iron are associated with clay-forming minerals. So we can say that potassium and iron, these two elements can be considered as a major constituent element of our slip or our outer surface, our sparkling beauty, where we see sparkling beauty of our pottery. Well, why we compared a result of brick and our NBPW? Brick and NBPW both were taken from same site. Brick is considered, brick and clay, both brick and pottery, both are made from same clay. And bricks were manufactured at large scale. So we assumed that for making bricks, locally available clay were used. But pottery can be made locally as well as can be taken from outside also. So if we determine the chemical composition of brick sample and compare with NBP sample, and if both are matching, then we can assume that our NBPW has the same elemental configuration, elemental composition like brick. So both are made locally. So we conducted preliminary analysis with laser-induced breakdown spectroscopy. Here our sample 137, this is a brick sample, and this is NBP sample, and both are found with same origin. And this data were confirmed with ICP-MS. In ICP-MS, we used rare earth elements analysis and confirmed that both NBPW and brick both have same composition, same set of rare earth elements. So we can say that such type of pottery can be found in closed firing pit. And in order to create black color and glaze, so for creating black color, first these pottery were fired in reducing atmosphere, and after that kiln were opened and temperature exceeded around 1200 degrees centigrade for some time, and it allowed to cool very gradually, very slowly, and thus the black gloss layer was originated. So this is our result. Thank you.
I'd like to welcome our third speaker for this session, Dr. Aude Favereau, who is Assistant Professor at the Institute of Archaeology, National Cheng Kung University in Taiwan. And the title of her paper is From the East to the West, Investigating the Presence of South China Sea Ceramics in South Asia.
No, it's okay. I'll just keep my notes, but... Thank you very much. Good morning, everyone. So first of all, I would like to thank the organizers of this conference. And in this presentation, I will investigate the possibility of the presence of South China Sea ceramics in South Asia. So we already have in this conference some presentations which highlighted the complexity of interactions between communities in the Bay of Bengal and in the South China Sea over time. And these presentations discussed the movements of people, of goods from South Asia to Southeast Asia by the end of the first millennium BCE and the beginning of the first millennium CE. And the presentation highlighted complex cultural interactions involving the exchange of artifacts, but also the dissemination of technologies and style. Less has been said on the circulation from the South China Sea to South Asia. So this presentation aims at tentatively investigating the topic based on ceramic data sets from the South China Sea area that are dated between the 2nd millennium BCE to the early 1st millennium CE. And there will be a special focus on the period from the first millennium, mid-1st millennium BCE to the early 1st millennium CE. So as discussed in the joint presentation that Professor Bellina and I made earlier in this conference, different levels of interactions and responses to interactions between the Bay of Bengal and the South China Sea communities can be evidenced as early as the mid-1st millennium BCE through the identification of technologies and the reconstruction of chaînes opératoires, so the manufacturing techniques and the way they're made, and the comparisons of the different productions in southern Thailand and Myanmar. So those included the local and imported and hybrid ceramic production, hybrid productions. When I talk about hybrids, I mean in this presentation, productions that are mixing South Asian and Southeast Asian features. And South Asian related ceramics have been discovered on several sites of the 1st millennium BCE, early 1st millennium CE in Southeast Asia. Some sites, such as those that are located in southern Myanmar and southern Thailand, are facing the Bay of Bengal. And they yield actually a significant quantity of South Asian related ceramics. Other sites that are facing the South China Sea yield less South Asian related ceramics. But it is likely that the circulations were not just one way. It is likely that it was not just west to east, but also east to west. So this presentation aims at questioning whether South China Sea ceramics or ceramic technologies or ceramic styles were from Southeast Asia, from the South China Sea area, were adopted in South Asia. So a few questions that I hope to raise. So do we have some ceramics that travel from the east to the west during the 1st millennium BCE? And also, can we find South China Sea inspired ceramics in South Asia? And what were the South Asian groups' response to the presence of, the potential presence of South China Sea communities along their coast? So, although the topic of these early archaeological exchange, so from the South China Sea to the South Asia, has been little tackled, as I mentioned earlier, we already have some archaeological evidence, of course. So for instance, there are some studies that reported that perishables like spices were traded from the Indonesian island up to Rome around the first century CE. And we also have scholars such as Professor Salvakumar, who documented the presence of boats that was made locally in India using non-local technological elements that Professor Salvakumar believes may be from the South China Sea area, maybe South China Sea related. As for ceramics, we also have several scholars that discussed the presence of ceramics in India that could be linked to Southeast Asia. So, in this presentation, I will first review some ceramic types of the late 2nd millennium and 1st millennium BCE in South Asia, reported in the literature. So I will rely on the literature because I haven't seen materials by myself. And I will look what is said in the literature, what are these ceramics that are showing parallels with the East. And I will tell you what is known on these vessels in Southeast Asia. So of course the presentation does not claim to be exhaustive because there are a lot of ceramics in South Asia, and I'm not aware of all this variety, but the idea is rather to further open the discussion on that topic. And then I will introduce a selection of ceramic types that widely circulated across the South China Sea area, and that were also found on sites in Southeast Asia that are facing the Bay of Bengal, so in southern Myanmar. And the question is, so the goal here is to introduce significant ceramic productions from the South China Sea that perhaps are present in South Asia, but they have maybe not been clearly identified yet. So I will introduce these productions and I will propose some comparisons based on some similarities that I spotted in the literature. And of course, these are tentative comparisons because they are based on morpho-stylistic features. So the presentation focuses on South China Sea ceramics, which encompasses several coastal areas of Southeast Asia, but also Taiwan and southern China. And I will mention different corpuses from southern Thailand, Myanmar, and also Vietnam, Philippines, and southern China, Taiwan, Borneo. And a special attention will be given to ceramic assemblages from southern Myanmar and Thailand. So this is part of the Thai Malay Peninsula. Because in this area, more than 80,000 fragments of ceramics were analyzed. They come from more than 20 sites that were excavated or surveyed by the French, Thai, Burmese archaeological team. And a major asset of this area and of the Isthmus of Kra, so this small area here in particular, is that this is located right between the South China Sea and the Bay of Bengal. This is a narrow piece of land, and in this area we have significant archaeological sites. And the team excavated on both sides of the peninsula. So some sites face the South China Sea, others face the Bay of Bengal. And thanks to this strategic position, we can see sites with different materials. For instance, the sites in southern Myanmar, so along the Bay of Bengal, they have delivered more ceramics that are potentially connected to South Asia, while the sites that are facing the South China Sea area, they have different ceramics, different corpuses that are more related to the South China Sea area. So I divide my presentation into 3 periods. But there are some ceramic types that span over several periods. We will see that. So period A, which is the 2nd millennium BC, which is labeled Neolithic in Southeast Asia. Period B is from the 5th to the 2nd century BCE, which correspond to late prehistory in Southeast Asia. And period C, 2nd century BCE to 2nd century CE, which is a transition between the late prehistory and the early historical period in Southeast Asia. So let's talk first about ceramics recovered from South Asian context and reported in the literature as potentially linked to the South China Sea area. And as far as I am aware, there are 2 main productions that have attracted attention. Tripods on one hand, and impressed ceramics on the other hand. So the tripods, they are these vessels with 3 legs, and they have surfaces that are often impressed with corn marks. And in South Asia, tripod vessels attributed to the Neolithic are reported in Manipur states, northeastern India by scholars such as Professor Azarika yesterday. He showed us more tripods from northeastern India in his presentation. And these tripods, they are associated with a TL date of the 2nd millennium BCE. And so these are, you can see on the left, the tripod for northeastern India that were already shown yesterday. And they are found together with that kind of Kodmar ceramics. Here on the right, this is an example of tripod from Thailand, southern Thailand, and they are also associated with Kodmar ceramics. But the chord marks, they are a bit tricky because they are documented for various periods, different areas. So I won't focus on that now. I will focus on the tripods, because tripods, they seem to only occur during the Neolithic period. And also, they have this unique aspect with these 3 legs, with these chord impressions. So they are quite useful to discuss similarities. So let me tell you about tripods in Southeast Asia. They are reported only during the Neolithic, and in fact, they have a limited distribution area. So they are known from the center of Thailand at sites such as Nong Ratchawat in Suphanburi province, or Ban Kao in Kanchanaburi province, to the south in Malaysia, so around here, in Kedah State, or sites such as Jandaram Hilir, or in Selangor State. So in short, these tripods, they are found in central Thailand and in the Thai Malay Peninsula only. And in the Isthmus of Kra, the Kra Isthmus, there are a lot of sites actually yielding tripods that we excavated with the Thai-French team. And the sites, they are dated of the 2nd millennium BCE, although some dates go back as far as the mid-3rd millennium BCE. So about these tripods, in the Isthmus of Kra, they are mostly found in inland caves. They are associated with burial context, but they also occur in open-air sites, also inland open-air sites, open-air inland and coastal. And we conducted analysis to identify how they were made. We also plan to conduct compositional analysis of the raw materials, but the research is ongoing. But regarding their manufacturing, so they are made of slabs, of coils that are joined together, and there is a small attachment cone that you can see located on the bottom of these vessels. There are 3 of them actually, 1 cone for each leg of the tripod, like some kind of small projection. And the legs themselves, they are made with slabs of clay that was rolled up on themselves. So these make hollow tripods. The legs are hollow. And then they were glued to the base of the vessel with more clay that was added. And the tripod legs, they are drilled. And it is still not known whether all tripods in Thailand and Malaysia were made the same way, because what I'm talking about now is more those in the Isthmus of Kra. But about the others, it is still not known. So we don't know if there is more than one tradition in terms of manufacturing that can be identified. We need to conduct more comparisons. But based on descriptions from reports, there are differences that can be spotted. So now we need to conduct further comparisons to tackle this issue, and perhaps in the future to compare with those from northeastern India, so that we can go beyond the morpho-stylistic similarities. So regarding the size and the shapes of these tripods in the Isthmus of Kra, again, there are variations within corpuses. So variations within the Isthmus of Kra, but also when we compare with other sites along the Thai Malay Peninsula. So you can see legs, they have refined but not necessarily pointed tips. Some are very high, others are short. They have a different angle. Some legs are almost vertically installed, others are not. And also, in the Isthmus of Kra, there is only one hole that is drilled in the legs. But in other areas, for instance, in central Thailand, you can have 2 holes that have been reported. Also, when you look at the vessel, not the legs, but the vessel itself, the body, we can see different shapes. So it can range from shallow, open vessels to closed vessels with higher walls and carinations. And the lower body of the vessel and the feet are usually impressed with the corn marks. So finally, it is also interesting to note that at some sites, such as Ban Kao in central Thailand, there are numerous tripods that were found in non-burial context. So it's different from I told about the Isthmus of Kra. So this might suggest a different function compared to the tripods of the Isthmus of Kra. So where do this tradition comes from? This is still debated. Professor Manjil also mentioned that yesterday. If this is a pottery form, a pottery shape that is rare during the Neolithic in Southeast Asia. However, in China, during this contemporary period, during the same period, we have ceramics with 3 legs that are found on several sites, especially within the middle and lower Yellow River Valley. And so this has contributed to speculations about the potential links between tripods from China and the Tai Malay Peninsula. But so far, there is no formal link that has been established. However, it could be interesting to take a look in the future, a closer look. So let us now talk about impressed ceramics. So in South Asia, we have seen presentations in this conference, and we can see that they are documented on several sites. In mainland and Southeast Asia, they are also documented on a large number of sites, and they are widely found through time. So it's a complex topic to discuss. In Southeast Asia, they are found from the 3rd millennium BCE to the 2nd millennium CE, so it's a huge chronological range. But for this presentation, I focus on the period B or C that I defined earlier. So this is 500 BCE to 200 CE. And let me talk first about those tripods in the Tai Malay Peninsula, because that's those that we investigated closely. They are found mostly, not tripods, sorry, impressed ceramics. I think I just said tripods. So in the Tai Malay Peninsula, impressed ceramics are mostly found in habitation context on sites involved into trade. And they represent about 8 to 10% of the total ceramic production in the Isthmus of Kra. So during this period, 500 BCE to 200 CE. And there is a variety of pottery pastes within the group in all sites. So this suggests raw materials of multiple origin. Some vessels may have been produced locally, others elsewhere, still unidentified. So these pots, they are formed using coils, and then they are shaped with a paddle and anvil. The rim is smooth with rotation gesture, but there is no wheel that was involved. And the outer body walls, they are covered with overlapping patterns, usually. So they are impressed with carved paddles or paddles around which a cord was wrapped. So there are different kinds of impressions. And these impressions, they will create various patterns that I will discuss in more detail now, because elsewhere in Southeast Asia, the data is heterogeneous. It is likely that the productions, those impressed ceramics, they were made using various techniques across all Southeast Asia. And we don't have large-scale comparisons, so definitely we need. But for now, what we have is that many different impressions have been documented in Southeast Asia. And we can see that a few designs are shared over several areas. So these designs, I will introduce them one by one now. We have cord marks, impressed lines, crisscross lines, grid patterns like square designs, and geometric designs. So let's start with the cord marks patterns. So you can see, so on the right, these are samples from the South China Sea area, and so we can see the cord marks. They are found in many sites, like in many areas, central Vietnam, Angkor Borei, which is in the Mekong Delta. It's also found in southern China and also in the Philippines. And so, as I mentioned earlier, I try to make comparisons with what I can see from the literature in South Asia. And for instance, we can find the cord for the same period. The cord mark pattern is also identified on this site of Alagan Kulam, for instance, that is contemporary with those sites on the right in Southeast Asia that I mentioned. The line pattern now, the impressed line pattern. So if you see on the right, we have some example. This is a site that is actually in the Thai Malay Peninsula that is facing the Bay of Bengal, the site of Maliwan. And then we have different sites, so in the Philippines, in Vietnam. And you can see that this pattern that we find in Southeast Asia is actually very similar to those shirts from Archaeological that are probably the same period, if I'm not mistaken. About the crisscross pattern, again, so I propose this comparison with Archaeological. And you can see this crisscross pattern is also found across Southeast Asia, in the Thai Malay Peninsula, Vietnam, Mekong Delta, and peninsular Malaysia. So actually this pattern, I would say, it's in mainland Southeast Asia, but I haven't seen it yet in island Southeast Asia. This square pattern, so we find it especially in the Thai Malay Peninsula, and I found these interesting comparisons in Alagan and Arikamedu in India. And finally, geometric patterns. So maybe a bit more complex because of the periods. The dating is not 100% clear, but I found it interesting to compare. So in the South China Sea area, actually, it's in southern China. We have those samples that, if you look at the pattern, is actually quite similar to this one in Kotapatnam sites of India. And also those samples, so it's a site from southern China, they are also quite comparable, quite similar to the same site of Kotapatnam. Those samples in southern China, they are dated pre-Han Dynasty, so this is before 200 BCE. If I'm not mistaken, those samples from Kotapatnam could be contemporaneous, but maybe we can discuss later. So let me tell you now about other ceramic types that I did not find reported in South Asian literature, but they are ceramic types that circulated widely across the South China Sea. So let's see if we can say something about these types compared with South Asia. So there are 4 that I want to introduce. And let's start with Sawin-related ceramics and Kalanai-related ceramics. I don't know if you heard about those ceramics. They are super famous in Southeast Asia because they are found everywhere. But originally, Sawin is a site in central Vietnam, and Kalanai is a site in the central Philippines. So why I introduced them together? Well, they are actually, you can see they have different time period, but still overlapping. Like Sawin ceramics is from 500 BCE to early 1st, 2nd century CE, and Kalanai is more 400 BCE to 200, 300 CE. So they are overlapping. And what is interesting is that they do share a lot of decorative motifs. You can see on the left, bottom left, you have some patterns from attributed to Sawin and others attributed to Kalanai-related sites. And they are quite similar. But in terms of technologies, they differ. So there are definitely different things. So let me show you some more patterns so that you can have an idea, and maybe you will think, oh, I have seen that in South Asia. So these are some typical Sawin patterns, and they are, the most common are incisions filled with impressions or with painting, or filled with more incisions. And then these are some of the typical motifs. Like you can see the picture on the right, it's a carination, and there are some, these like scalloped decorations that are carved on the carination. And on the left, they are incised with a tool with two tips actually. So there is a rotation that is made. It's quite typical. So usually, if you see them, you will be able to identify them easily because they are very typical. So I try to see if we can find them in South Asia. And this is very tentative, and it's only morphostylistic. But this is, so you have an example of Samhain decoration on the right. Typically Samhain related decoration with incisions that are filled with more incisions. And this is a sample from Arikamedu site. And well, I found this is interesting to mention because maybe there are more and we are not fully aware of them. So that's just one example, and they are contemporaneous. One more example about Samhain. So on the right, this is also a typically Samhain. You have these incised bands that are structuring the space, and they are filled with impressions that are made with the edge of a shell. And I found in the literature this sample from Odisha, also with these incised bands and filled with wavy patterns, probably with the edge of a shell. So and could be contemporaneous from what I could see in the literature. So interesting to keep in mind. About Samhain, about Kalanai. So the Kalanai, I mentioned earlier that one typical pattern are those carved decoration along carination or borders. And so this is one example from Arikamedu that we can see. But I would say the comparison is not really good. I mean, it looks that there is something similar, but in terms of techniques, it's definitely different because in Arikamedu, Professor Begley documented, and she explained that this was impressed with textile, and this is definitely not the case in the South China Sea area. The decoration are shaved with a sharp tool. So we have different ways of doing, but still there is some similarities to consider. So let me talk now about black and red burial jars. Very typical in the South China Sea area. So the way they are made is very specific. They have a fabric that is tempered with organic materials. You can see on the top left. So plant materials. And what is very typical, so if you look at these two pictures, there are some small bubbles, right? This is the internal surface of the fragments. So how do we got that? It's because a convex mold was used to manufacture the lower part of the jars. The upper part was manufactured using large coils and slabs. And then we have the base and the body that were paddled. You see on the right, this is one example of one of these jars, complete jar. So the scale, it's showing 10 centimeters. So they are big jars, like very big burial jars. And on some of them, the presence of a vitrified slip was reported on the outer surface. And they are always decorated. We have impressions, sometimes incisions that are made with a comb. But regarding the impressions, this is interesting because we believe Dr. Phaedra Bouvet and I, so she was the one who also studied these ceramics before me, we believe that the decorations could be roulated, made with a roulette. But that kind of technique, like roulettes, is not really common in Southeast Asia. Let me finish with the technological description, and then we will talk about techniques, not local techniques. So these jars, they were fired in reduction and oxidation. I put a picture here, but this is not very clear. But what is very common, and that's why we call them black and red, is because we will have one face that is red and the other one that is darker, but not very black actually, it's darker. And that's why they are called black and red. And this is a technique, Okay, this is a technique that is actually not common in Southeast Asia. So, in the current state of research, these vessels, they are interpreted as produced. We don't know if it's locally or not. But definitely, we believe that they were produced by non-local potters using exogenous techniques, exogenous technologies and style. So these vessels, the samples that I show, they are from the Thai Malay Peninsula, but they are also reported in Vietnam and in the Philippines. And these technologies, like the roulette, the black and red, vitrified slip, they are known in South Asia. So that's the reason why I considered potential links with South Asia. And looking in the literature, there are a few samples that I found very interesting. You can see the sample here. This is a sample from Bahiri site that was excavated by documented by Professor Gangopadhyay. I'm sorry if I'm pronouncing not very well, and colleague. And the description explained that this is the internal surface, while the external surface was incised with lines. So you can see we have a very similar situation for our black and red jars. The inside is with those bubble-like decoration, like that were made with the mold. And outside, we have incised lines. And I also found this sample from Kotapatnam is actually quite similar. And also the surface aspect, I don't know if this is the same reason, but in Southeast Asia, it will often be linked to the raw material, the temper, organic temper that will create that kind of surface aspect. So I wanted to raise the comparison. And one more comparison is about with this sherd from Arica Medu. The surface is actually quite damaged, but could be compared with some of the damaged surface in Southeast Asia. And Victoria Begley, Professor Begley, mentioned that those fragments that are very rare actually at Arica Medu, they also have organic inclusions, just as our black and red jars. So let me talk about Han ceramic now, our last example. So the Han, so when I talk about Han, I mean Han Dynasty in China. So this is 2nd century BCE to 2nd century CE, roughly. And so those ceramics, they have been found of course, they come from southern China and northern Vietnam, which is the area that was occupied by the Han Dynasty by that time. They have been found in Vietnam, Indonesia, and in the Thai Malay Peninsula. In the Thai Malay Peninsula, they come from port settlements. And they are imported, of course. And they have a very fine fabric. The vessels were shaped with large coils. They were paddled and smooth. And common decorative technique are impression and incision. And some of them, they will have a seal on top of the impressions. So I want to mention that a single morphology has been identified in Southeast Asia. These barrel-shaped restricted potteries with flat bases. So they can have different dimensions, but most of the pots are rather small, less than 20 centimeters. And such a shape associated with the fact that there are also slip inside of the ceramic could suggest that the vessels were used for storage. So my comparison is with Arica Medu, eastern coast of India, and perhaps Kotapatnam, but I'm not sure for Kotapatnam because the thickness, I don't know about the thickness, and it matters because these they are very thick, sometimes can be about 1 centimeter thick. So I will go to the conclusion and I will briefly summarize. But this presentation provided some potential avenues for comparative research between South and Southeast Asia. Now we need more comparisons based on homogeneous data, including technological data, fabric analysis, and detailed morphostylistic studies, as well as reliable dating. So there is a lot of work still to be done. But this would allow not only to identify the potential South China Sea-related predictions in South Asia, but also, if any is identified, to distinguish between importations and hybrid ceramics. As we already emphasized in the joint presentation with Professor Bellina, it is particularly important to study hybrid ceramics because they do not have the same cultural meaning, different interpretations, compared to what imported ware can tell us. So in terms of connections between different communities, it's very important. So to finish, I made 3 slides to show you through times the different connections, looking at different materials. So the tripods for the 2nd millennium BC, so we can see potential connections between the Tai Malay Peninsula and northeastern India. And then the period that is more confused, like from the 5th century BCE to the 2nd century CE, like we seem to have a lot of things that could be compared. So they have different areas of distribution in Southeast Asia. I did not include Indonesia, but it doesn't mean that Indonesia is not concerned. It's just that I'm not enough familiar with assemblages from Indonesia. And you can see that there are things to say about this area and this area in India and also the southern India, but I'm not saying that there is nothing here. It's just that I'm not aware of what is happening in this area. Probably there are interesting sites that could be compared to. And finally, the China-related ceramics. So they are imported from southern China, northern Vietnam. They are documented in this area in Southeast Asia. And they are found potentially in these places in India. So I just made potential routes, but of course this is all a suggestion and hypothesis to discuss in the future. Thank you very much for your attention.
Friends and colleagues, I have been informed that everyone, especially at the back of the room, will take precisely 2 minutes right down to make a note of your questions, so that especially the students can ask Professor Krishnan, Professor Rai, and Professor Favereau their questions after the next panel, which is also on the same theme. So I believe tea is ready. I have been informed that we will do the collection collectively, but I will say we've had 3 incredible presentations. Please write your questions down so that we can do it collectively.
सर वो आग जलाने या लाइटर लाइट
स्मोक करता है सब लोग करते हो दे दो मैचेस लेकिन पेपर पेपर इसके पास पेपर है
अभी इनसाइड होंगे
एक एक करके अलग अलग करके लेना एक साथ जला मत देना रखना पड़ेगा आपका मत चले जाइए go little back so everybody can see no you can take photographs that's fine थोड़ा थोड़ा पीछे चले जाओ सबसे अच्छा बाजू में जो चल रहा है
ये लास्ट में अगर हम सरसों का तेल ना
डालने के टाइम में बोलते जाओ क्यों कर रहे हो क्यों कोयला डाले system. So that much cow dung cake is putting, how much he thinks the firing, the temperature will be required.
So they have applied any slip, no? Like they have applied some.
Sir, a slip they have applied, which is made of mango leaf. This is goat dung. So it will become, and this is the best one, cow dung. You get this dung, and she is putting the dung. That gets you the black color. Goat dung. More than anything. He's putting all those. All of you can go to one side so you can see. He's doing from that side. This is goat dung. You can go that side, can see that. What is going on? कैसे हो गया आप शादी किए ना आपका बच्चा हेलो see that he is putting this goat down everywhere
पकड़ लेगा ना
वो लाए नहीं क्या जो थर्म कॉटन
गीला पकड़ रहा है सुलगा दाल से
अभी तो कागज भी खत्म हो गया आपका
बड़ा सर्कल बना दीजिए भाई
नहीं है ना इधर अंदर ना
बांस की पत्ती
then bamboo leaf.
और उसके बाद एक जंगली पौधा होता है जिसको अड़सा बोलते हैं, उसकी पत्ती।
There is one leaf called poda. Called
सर अड़सा
arsa. He's not able to say the English name, but arsa, one can Google what is arsa in English.
और वो ये सर जो ऊसर भूमि होती है उसकी मिट्टी
Then ray. You know ray?
सोडा काले
That pus and ray, which is used for making glass, glaze. You can see that what is doing.
ओके
सरसों का तेल लगाकर जब ये सूख जाता है तो ये ऑयल को लगा कर इस पे चढ़ाते हैं, फिर वो फिनिशिंग सूख जाएगा नहीं, इससे शाइनिंग आती है। वो भी देखिए कलर छोड़ेगा और इसमें फिनिशिंग है, जो भी एक्स्ट्रा रहेगा कलर वो छोड़ देगा। दावा चला था हरवा की सर
सुनो छोड़ो ना
नहीं फाड़
और पत्र तुम्हें कितना बोतल वाला चाहिए? कितना वाला? हाँ खोलो। हो गया? चलो हो गया ना? इसको बहुत पतला करूँ?
डिजाइन करके
करो ना।
अरे निकल जाता
It is a furnace cotton.
Mudit Trivedi, and I think we can all start again by thanking Alok, IIT Gandhinagar, IIT Madras, and especially the Tamil Nadu State Department of Archaeology, who have made us so welcome here. And it is my pleasure to introduce as today's first speaker, someone who has trained generations of ceramicists in India, Professor K. Krishnan, whose the topic of whose paper is Scientific Analysis of Archaeological Ceramics. don't mind if people are picturing it without few minutes. We'll just keep going. Do you want to... All right, welcome back everyone to session 7, part 2. Our fourth speaker in this two-part panel is Ritvik Balvally. And Dr. Balvally's paper is titled Provenience Unveiled, Exploring Torpedo Jars Through Geochemical and Petrographic Analysis.
So firstly, Vanakkam and Namaste to everyone. I'm Dr. Ritvik Balvally, and this is a collaborative work that we took up with my colleagues in France, as well as my Indian colleagues, and we're trying to find out the provenance of torpedo jars. I suppose already there were some papers that dealt with torpedo jars, and I'll be looking at some of the analysis that we did for the material from South Asia, and specifically from Western India and a site from Central India. So what are torpedo jars? I won't go into too much details, but if you do look at it, temporally they start all the way from the Parthian periods, and then it extends into the Sasanian as well as the early Islamic, so that would be around 2nd century BC, all the way till you have 10th century and even further. But across this journey of this jar, it does go through typological changes, which can be mapped temporally. So when we do get jars from India, we get a very specific set of jars which are certainly Sasanian, and maybe if you want to put a question mark on it, early Islamic in nature from certain sites. So what are the features of the torpedo jars? What exactly defines a torpedo jar? So you have a bitumen lining that is there. So if I could direct your attention to the lining that is there within this jar, you have bitumen that is lined within it, and these jars, of course, lack handles. So if you compare with your Roman amphora, so within Roman amphora, it's very important that you would find these handles, and handles is a big part of understanding the typology of Roman amphora and other amphora, Greek, etc., etc. But the feature with torpedo jars is that they're usually handleless, and they don't have a neck as well. So initially, when they do use these jars, they were certainly used for storage and transporting, but you do have secondary use within West Asia. So if you see the site of Boucher that is near the coast, you do have them being used as ossicles and, for putting bones, which were then buried. So this is like a reuse that we see for these jars. Within South Asia, if we see, the chronology goes from 3rd century to 9th century AD. So these are some of the shapes that you find. Sometimes you would find outspill of the bitumen onto the rim and onto the brim as well. And if you see the kind of base that you have, you would certainly say this is sort of similar to what you find in the Roman period, or jars which were used for ship transportations. But this is not the only ceramic material that does come to South Asia. So you have a wide range of material that comes to South Asia, and this is just my map of Western India. So all these sites that you have either torpedo jars, or you have some material that may belong to the 10th or 9th century AD, or even further. So this is like a sgraffiato, if you see. And these are some glazed wares that we have found which come from West Asia. So this is not exclusively the material that you find in in Western India. So these are all the sites that I've mapped out. And from these sites, we'll be looking at, or we tried to look at some preliminary studies. So we took about 19 samples, sorry. And you have majority sites which are in Gujarat, that's in Western India. And there is one site that is almost 800 kilometers away from the coast, that is in Nagardhan, that is in Nagpur, that is in central India. So from Vallabhipur, I won't go into the details too much. It was excavated by the Department of Archaeology and Ancient History, MS University, Baroda. And you have different periods and different areas within Vallabhipur. So these are some of the dates that you find. And this is the quantification that I have from the site. So you have two varieties of macro fabrics that I have noticed from the area. This is Kanmer. So Kanmer, as Professor Kanoya was saying, why isn't Kanmer being put up for torpedo jars or early historic materials? So Kanmer certainly has torpedo jars, and the central areas within Kanmer are a better context, and these would have been radiometrically dated to about 3rd, 4th centuries AD. So whatever you're finding after that, that is when you're finding the torpedo jars as well. So Vadnagar, already there have been papers on Vadnagar. So I have looked at the material from the State Department excavations. So Vadnagar not only has torpedo jars that you see here, you also have some glazed wares which come from Vadnagar. And this is the site of Nagardhan. So Nagardhan is a very interesting site because it was the capital of the Vakatakas, and it was called Nandivardhan in that time period. This is what the excavators claim. And it was at the greatest extent about this time period, and this is exactly when you start finding the torpedo jars. So if you see this level, that is when you get the torpedo jars. So we did some analytical procedures. So not only on the bitumen, we also tried to look at what the ceramic might contain in terms of mineralogy and clay. So the first study is about bitumen. So we tried to extract some organic matter from the bitumen to try to see if it does have any bitumen that is left. So when you're doing that, you first get two things. You get resins and asphaltenes. So these are two different things. So resins are sort of polar and sticky, whereas asphaltenes are non-polar and rather harder. And the unusual high ratio of resins to asphaltene, these samples suggest they haven't been significantly altered by natural processes like oxidation or biodegradation. So that's important to understand how it has really survived. And then later you also study the carbon isotopes to sort of get where these oil seeps actually are from. So these are sorry for the technicalities, these are the terpenes and steranes. So these are actually biomarkers. So you have two types of biomarkers that we see. So biomarker 1, A, that is you see here. This has a different sort of a feature from what you find from here. And this is found both in Iran and Iraq, whereas this is exclusively found or mostly found within Iran. And then we go on to something called as aromatics. So if you see the aromatic data that we've been putting up here, so these give you like, the analysis of the aromatic compounds suggests some biodegradation, but the overall patterns are similar across different sites. So this indicates a possible common source for the bitumen that is available. Now on to the thin section data. So already Professor Krishnan laid out all the kind of work that is being done for thin section data. So we selected all these samples, and we're getting two fabrics, but they are closely related. So if you see, this is what the fabric looks like. So this is in XPL, that is cross-polarized. And this is the second fabric. So this is in plain polarized light. Apart from that, we also try to compare as to where it would fall in by using PCA. And if you see the material that is in black, that is where our samples are actually falling in. And we feel, while after comparing with the ceramics from different regions, that it is closest with the material from the sites, that is Jamdat Nasr and Uruk. And this is very typical of the Tigris River, the kind of features that you find there. So you have high chromium, cobalt, and it's lower in calcium and uranium. And also, the torpedo jars tend to be lower in potassium, rubidium, and cesium than a number of samples from Ram Hormuz, that is a little far away into Iraq, but not all sites in the Susiana plain. So now Susiana plains is something that I'll be talking about as well. So this is your Susiana plains, that is in southwest Iran. So bitumen characteristics from torpedo jars match the oil seeps in Iraq and Iran to some degree, but specifically from Kermanshah province. And there's a closer resemblance to a specific oil seep that is in Khuzestan. So this is Khuzestan. Because it has an abundant C27 diasterenes, a feature that is not found in Iraqi oil seep. So that can be, in the future, a way to determine where it is actually coming from. And it is likely that the bitumen from Indian archaeological sites came from regions like Khuzestan and Fars. So where you have this diasterene-rich oil seep that exists, such as Masjid-e-Suleiman, Lali, or Baba Kalim oil seeps. And then there was no direct correlation found between the type of ceramic fabric and the geochemical properties of the bitumen used in these torpedo jars. So I'll explain to you what that means. So at the moment, if we look at the Provenience, this is where probably, at the moment, where the jars are being produced. So that is where the body is being produced. But where are all your sources? And this is multiple studies. This is not the first time this has been studied. This has been done from Anuradhapura. This has been done from other sites. And this is an independent study now. All suggest that they are mostly coming from this region of Khuzestan and Fars. So now why is it that probably they are being made somewhere and something else is being spoken about? So long back, 6-7 years back, I went to Iran for this very specific reason, to study the ceramic material from this area. So this is what I found. So this is the material that I recorded. So if you see typologically and even in terms of macro fabric, it is quite gritty in nature. So Priestman also talks about this. He calls it the I have found, which is similar to what you find in South Asia. So what I did was, I was given some samples by Henry Wright to analyze. So I wanted to compare, or rather see, why and what is this gritty matter within the torpedo jars. Is it similar to what you find from the torpedo jars that we find in South Asia? So they are quite different. So if you see, these are mostly cryptocrystalline silicas with some secondary deposit that's have come into the fabric. So this is what the fabric looks like, and it is bimodal nature as well. So that suggests a different type of technology of mixing probably. So now the discussions, we do talk about where it is coming from and what is happening. So this is one more disclaimer. When you say torpedo jars, it is not just one type. There are different types of torpedo jars, and it sort of depends on where it is being made, in what period is it being made, and what region it is being made. So we see there is regional differences within the torpedo jars as well. And then what was it used for? So we were discussing that probably it's mostly a wine, a transport vessel. But I also wanted to discuss why could not it be also to transport bitumen? So that can be one more question as well. But we haven't found much bitumen within South Asia from this time period. Before this, the use for bitumen within South Asia is from Mohenjo-daro, where you have bitumen within the lining of your great bath. After that, you don't find much of bitumen here. So the contents always are going to be a challenge. So when I was thinking and looking at it, so this is a metal wine ewer from Iran. So if you see that they give the whole process of making wine, crushing it, and eventually they are pouring it into these jars. So these jars look eerily similar to torpedo jars. So my contention would be they might have been used for multiple things, but wine certainly could have been one of them. Thank you.
It is my pleasure to now ask Dr. Laure Dussubieux, pioneering archaeological chemist, leading archaeometrist, pioneer of the use of LAICPMS, and a wonderful teacher, which I can say personally, to present a paper entitled The Elemental Composition of Late Medieval Glaze on Ceramics from the West Coast of India.
All right. Good afternoon, everyone. First, I would like to express how honored I am to be here among so many eminent specialists of Indian ceramics. And I would like to thank for that the organizer of the conference, Dr. Rajan, that welcomed all of us in Tamil Nadu, and Dr. Kanungo. I would also like to thank Dr. Rawat, the current director of the Archaeological Survey of India and formerly the director of Gujarat State Archaeology Department, as he facilitated this project in many ways. So for those of you that are familiar with my research, you know that I'm more a glass specialist than a ceramic specialist, but there is an area of ceramic study where glass knowledge is extremely useful, and it is in the field of glazed ceramics. Some ceramics belonging for most of them to the medieval period in India are covered with a thin layer of glass, and those are not Indian ceramic, I'm sure you noticed. That was applied for two purposes. First, it is decorative, as it gives a shiny and colorful appearance to the ceramic, but also it has a practical purpose, as it makes the ceramic impermeable to liquid, allowing them to contain food or liquid. So here you can see the cross-section of glazed ceramic with the paste on the left. Here we go. So the base on the left, that is also represented here. And on the right, of course, the glaze. And in between, you have what we call an interface. In this interface, researchers have observed an interdiffusion of elements from the glaze into the body and from the body into the glaze. Glaze can be produced following different recipes, and therefore will have different compositions depending on the area of production and the time period. Major glaze families include, and it's not a full list here, alkali glaze with alkali element like sodium or potassium as a major element, lead glaze, or high lime glaze. The recipe of the glaze will have an influence on the firing temperature of the glaze, with low firing temperature glazes, which are the alkali glaze and the high lead glaze, and high firing temperature glaze, that will be the high lime glaze. So my colleague, Dr. Maninder Gill, talked a few days ago of glaze styles, which are a very similar topic, and all the information he shared about glaze technology for tiles applies to ceramics. Dr. Gill's presentation was focused on ancient coloring technologies. Understanding how glaze was made and how it was colored is an important area of research that contributes to our understanding of the mechanisms of innovation and technology transfers in ancient time. Using glass composition to track circulation and provenance of the glazed ceramic is another way to study glazes that provides information on exchange and interactions. Finally, understanding when a given type of glazed ceramic was made and for how long is a way to access chronological information. But at this point in time, the study of glazed ceramic is still in its infancy, and we lack comprehensive reference data, including glass compositions. And so it will take time before we are able to rely on robust comparative data sets containing data coming from well-dated and well-contextualized glazed ceramic spanning long periods of time. And in this study that I'm going to present, we will focus on specimens found in Gujarat, and we will look at the circulation and provenance of glazed ceramic. So first, I'm just going to have a small introduction about different analytical techniques that you can use to study glaze. And I will finish with LAICPMS that I use for this study. So there are several approaches that can be used to study glaze. A good starting point is just using a microscope at low magnification and look at the surface of the glaze to detect corrosion, to document bubbles and crack patterns, or to observe undissolved grains or neoformed crystals that are emerging at the surface of the glaze. There are also a scanning electron microscopy, and Dr. Gill gave us example of that to have a closer look at the glaze. That will give us additional information about the presence of undissolved phases, or that will allow for the observation of the interface between the paste and the glaze. And when the scanning electron microscope is coupled with energy or wavelength dispersive spectroscopy, elemental composition can be determined. And although that kind of instrument can only measure major and certain minor element, it is a good way to map the distribution of the element. We saw some example this morning not on glazeware, but on different ceramic. And that can be useful to understand technology of fabrication. Also, spectroscopic methods such as Raman that are totally non-destructive, by example, at the opposite of SEM that require that the sample is embedded in resin and polished. Raman spectroscopy can be just used on an unprepared sample as long as it has a clean surface, free of debris and dirt. And it can be really helpful to look at, to identify the different crystalline phases in the glaze, and some of them being opacifier to have a better understanding of the coloring technology used by the ancient craftsmen. And I think Dr. Gill also showed us example of the use of Raman to identify some of the opacifier he found in the glaze tiles he studied. So we used elemental analysis to study the glaze. That is the focus of this paper. And although there are several analytical techniques that can be used to determine the composition of the glaze, we are going to focus our attention on laser ablation and inductively coupled mass spectrometry, because that's the technique we use. So This technique has several advantages. It can measure a wide range of elements. We measure 58 elements. This element can be present as major elements, so it's several percent to 50, 60%. We also measure the minor element between 1 and 0.1%, and then also the trace element that are below 0.1%. And just for, I use the term of ppm on my slide, 0.1% equals 1,000 ppm, and we can determine elements that are present in the range of 1 ppm and below. So in the case of glazes, major and minor element concentration will be useful to determine what type of recipe was used to produce the glaze. So if the glaze has 10 to 20% of soda in addition of silica, it will be an alkali glaze. If the glaze has high concentration of lead, it will be a lead glaze. Trace elements are useful to determine subgroups. For example, if two workshops are using similar recipes, it is quite likely that they will use ingredients from different sources. For that, I can take the example of the source of silica, which usually is sand. Workshops are located close to a sand source because that would be pretty costly and time-consuming to bring sand from far away. So these sources will have overall identical composition as per their major and minor element, but because they will be at different locations, their geological environment will vary slightly, which will have an influence on their trace element signature, and we will use that to try to identify different workshops. And I think this is the illustration of what I just told. Something important when using LAIC PMS is that also it's necessary to sample material from the object under study. The quantities that are required are extremely small. We have two modes of sampling. The first mode is called single spot analysis, and that's what it's represented on the left. And in this case, the sample that is placed under the laser is still, and the laser will dig a circular hole that usually has a diameter ranging from 60 to 100 micron, which is similar to the diameter of one of a human hair. So it's not really big. And so that means that the trace at the surface of the object is invisible to the naked eye when the sampling is done. If we adopt this mode of sampling with glaze, it's quite likely that we will reach the interface and possibly the paste, which is not what we want. We only want the composition of glaze. So we use the scanning mode. In this case, the object is moved as the laser is operating, and instead of digging a hole, we draw a line, and only material at the surface of the glaze is sampled. In order to avoid possible corrosion and the presence of dirt at the surface of the sample, a first ablation is carried out with a larger laser beam, and after a reduction of the laser beam diameter, a second ablation is undertaken on the clean surface to sample pristine material. And here again, the trace left at the surface is quasi-invisible to the naked eye. So we used LAIC PMS to determine the composition of glazed ceramics recovered in the state of Gujarat. We focused our attention on the site of Bagatrav. The site of Bagatrav is close to the village of Ansot Taluka in the Bharuch district of Gujarat in India. The archaeological mound sits by a creek called Kim, which flows to the Arabian Sea through the Gulf of Kembat at a distance of 2 kilometers. This river also gives access to the agate-bearing mines and forested hills of the valleys of the rivers Narmada and Tapti. Archaeological investigation directed by Dr. Alok Kanungo under the auspice of IIT Gandhinagar were conducted at that site in May 2015 with two objectives. First, to determine the chronology of the site, and also to evaluate the functional utility of the site. So 3 trenches were excavated at different locations, and they revealed some Sorat, Harappan, and medieval deposits in 4 individual cultural layers. And the layers 1 and 2 are the ones that are of interest for us because they belong to the medieval period. The pottery assemblage in those layers is represented by red, gray, and glazed wares. And in the early level of this period, a few pieces of celadon and turquoise glazed wares were found. So red ware is dominated by jars and pots, followed by bowls and basins, whereas gray ware has a variety of jars, pots, and basins. In the case of glazed ware, only fragments of plates, bowls, and small pots were found. The glazed ware has 3 colors: white, green, and blue. The celadon and turquoise glazed ware sherds were found in the lower level of layer 2 that was dated with AMS radiocarbon from the 10th-12th century CE. And data currently available seems to indicate that this early occupation of the medieval period is restricted to the western side of the mound. This period gave sample evidence of lapidary activity in the form of agate, carnelian, rough arts, at different stages of bead production. It also yielded a number of otoliths indicating fishing activity. The 14th, 17th centuries monochrome glazed ware predominate the assemblage and were found along artifacts indicating that they might have been produced at the site. Another contemporary production site of monochrome glazed ware is reported at Lashkarsha. For comparison purposes and to understand where some of the glazed ceramics from Bagatrav come from, we also analyzed monochrome glazed ceramic from this site that were excavated by Dr. Kuldeep Ban from the University of Baroda. Lashkarsha, and I swear I really practiced to be able to say it, but and I don't know where I am anymore. Just give me a second. Okay. Lashkarsha is located in Kambat. Lashkarsha. Okay, so it's located in Kambat and was, bear with me, and was identified as a production center for monochrome glazed ceramics that was active between the 14th and 16th century CE. Okay, so 6 sherds were selected from Bagatrav, 3 were polychrome sherds. Green and black were analyzed separately for the 2 first sherds, and dark blue and white were analyzed for the 3rd one. The 3 other sherds were monochrome and included a celadon. That's the one at the bottom in the middle. 13 monochrome sherds were analyzed from Lashkarsha, but only compositions that correspond to local production will be considered here. So for Bagatrav, the glazes were silica-based with high concentration of soda for all of them, but one, that's the celadon, that you can see here. This one, so as it's silica-based with a high alumina, high lime composition, and so it can be separated very easily from the rest of the sherd. For the other glaze samples, we notice a quite wide variability of the soda concentration that range from approximately 8 to 16%. So that's soda here. This might be due to the, so this variation can be due to the state of preservation of the glaze, because as you can see, it's not always very pretty. And a consequence of glass corrosion is a depletion in alkali. So, but although that is a possibility, that also this variation can also be explained by just a variation in the glass recipe used to produce this type of ceramic, of glaze. Also, what it's interesting is this share not only have low concentration of sodium, but also have higher concentration of potassium compared to those. So that's why maybe instead of blaming corrosion for this very wide range of sodium concentration, it's quite likely that it's just different recipes that were used, or some variability in the recipe that was used. So yes, that's a higher potash concentration samples. So we added to the previous data, the data from La Charcha. And as you can see, if we only based our observation on sodium and aluminum, the composition of the monochrome glazeware from that site are very similar to the composition of the glazes analyzed from Bagatrav. So the composition, so here I only reported alumina and sodium, but if we look at other elements, what we realize is that globally the composition of those samples are very similar to the composition of what we call mineral soda high alumina glass. That is a glass that is manufactured in India from Ray. And if you remember Dr. Gill presentation, he mentioned that type of glass. So looking only at two elements, it's not really a good way to try to group glass composition. So we turn our attention to a larger range of elements, which are the same elements that we are using for the mineral soda high alumina glass to distinguish subgroups. So we look at magnesium, calcium, strontium, zirconium, cesium, barium, and uranium. The two first elements are major minor elements, and the other elements are trace elements. So we use principal component analysis to look at similarities between the sample from Bagatrav and the other samples. And what we see is three groups. Okay. So here we have the ceramic samples that had lower sodium concentration, but also higher potassium concentration. So if we look at all those elements, we can see that this sample is really different from the other. Here we have the sample from Bagatrav and the sample from Lashkarsha. And those samples from Bagatrav are the two monochrome glazeware. And as you can see, there is a strong similarities between those samples and the sample produced at Lashkarsha. So that could indicate that those two samples from Bagatrav were produced in Lashkarsha and brought to Bagatrav. Here we have 4 points coming from two different ceramics that are polychrome. And what we see is that the composition of these two ceramic samples are very similar to the composition of glass samples that we also found at Bagatrav. And although it is not published yet, what we found using elemental and isotope analysis is that this glass was quite likely manufactured in Gujarat. Also, a more precise location is not available yet. So it seems that those two samples were made with the same glass than those were glass ornaments, bangles more specifically, and were also local production of Gujarat, even if we don't really know where exactly in Gujarat it was found. So this is summarizing our finding. So we have a celadon, long-distance trade. That's not a surprise. We maybe not really need elemental analysis to figure this out, but that's interesting to see that Bagatrav had some long-distance connection. At Bagatrav also, there are monochrome glazeware, quite likely produced in Lashkarsha, and other ceramic, polychrome, those that were quite likely also made somewhere in Gujarat. So some evidence of glaze ceramic production was found in Bagatrav. So maybe we need further investigation to test the hypothesis that those were made in Bagatrav. And then there is a third type of ceramic that was made at an unknown location. Is it in Gujarat or elsewhere? This is not really possible to say at this point. So in conclusion, what we show with this study is that at Bagatrav, imported and locally produced glaze ceramics are present. Studying glazes provides a way to look at interaction and exchanges in ancient time, and can be applied to the medieval period in India. And we hope to be able to expand this study to other sites in Gujarat, including material from Vadnagar, to help reconstruct intra-regional exchange network in this region. Thank you.
All right. If everyone heard amongst the students, please coordinate with Alok and Anuradha to fill your form. All right. Please only coordinate with Anuradha ma'am for your TA. We have had 5 excellent papers, 5 incredibly detailed papers that are so valuable for introductions and for a state-of-the-art of how we should be asking questions about scientific analysis and microscopy of ceramics. We have extensive time for questions and discussion now. Okay, Alok is correcting and editing every word I say, so we have some time for questions. Who would like to start? Yes. Can we get a mic here?
Hello, thank you all for the presentations. My question is to the ma'am who presented third about the South China Sea ceramics. Hello. You had shown pictures of 3-legged jars with holes on them. Do we know the significance of these holes? What was their purpose?
Jars with the holes? Wait, which one?
The 3-legged jars, the tripod.
Ah, okay. No, we don't know. There are hypotheses. I think Thai colleagues all made hypotheses about the drills holes that it could be for the firing to facilitate so that it will not explode when it's fired. But there is no explanation for now.
Thank you.
You're welcome.
This question or other comment is again to Dr. Aude. Thank you for the presentation. It's lovely to hear from you. In fact, this tripod legs or three-leg wares, if we see in the entire Northeast, it is only found in few sites in Manipur. So rest of the Northeast or other places, we do not have this. And in some of the exhibitions from southern part of India, from Tamil Nadu, we have some tripod legs again from this place. You can have a look on them, so and then compare with those data from Southeast Asia.
You mean from South India?
Yes,
And
yes,
same
yes.
here.
These
Is it
are
also Neolithic?
in the context of megaliths. They were
okay.
displayed even here in the exhibition. There are some. Yeah.
Okay.
There are tripod as well as there are four-legged wares also. So
Okay.
you can see. And second point is, what are the other materials that you get along with these tripod legs in Southeast Asia? In the context of Manipur, we have all sorts of these axes or edges, stone axes and edges. But what about Southeast Asian sites? What kind of other cultural material you get?
Well, maybe Berenice will want to talk with me because she was the main investigator of these sites.
Merci, assieds-toi là. Well, I'm from they're Polish axes. Yes. Actually, there is no proper regional study of these Polish axes. And we must tell you that, unfortunately, all these burial sites have been looted and they are very disturbed. Yeah. So.
Yeah. Thank you.
What can be added is that there are some shell bank with some shell beads.
Okay.
That is what we usually find, these three materials.
Okay. And sorry. Yes. Yeah. Okay. Do you have the shell bangles here? Did it?
Yeah,
Beads,
yeah.
not the bangles.
Yeah.
Okay. They are the beads. Okay.
And
Thank
a
you.
few shell bangles too, but also disturbed. So.
No, beads is it. Okay. Yeah.
Further questions to any of the five presenters? Can you give a mic in the first row?
Thank you, Laure, for that wonderful presentation on the glazes from Bagatrao. And I was wondering if Dr. Gill is here. Has the analysis of blue glazed Delhi blue pottery with the glaze that looked very much like Delhi blue, but I don't know when that started and if that has been analyzed at all. One sure that she was saying is separate. Looks like Delhi blue pottery stuff, so maybe from UP area. So I don't know how early that Delhi blue glaze is from.
The Delhi blue glazes are not very old. I mean, are you talking about the Mughal Delhi blue, or are you talking about the
I don't
Delhi
know
blue
anything
pottery?
about the history of Delhi blue except I know that there's a Delhi blue.
What they call the Delhi blue is, colloquially these days, is a kind of pottery that developed in the 19th century and then was, brought into commercial use in the 1970s onwards. So Delhi blue is really not very old in that sense. It's an offset of what the Jaipur blue.
So then maybe Jaipur blue is older?
Jaipur blue is older.
So then,
but Jaipur blue is also probably 19th century, so I don't think there would be a relationship. Of course, they use the same kind of materials. It also has a footwear body, but the technology is different. It's more modern in that sense, yeah.
Okay, thank you.
Laure, would you like to add something? Mark, I can add that I am guilty of not having finished the analysis of the indoor glazedware ceramics, but that will be done in the indoor glazedware ceramics, we have some analysis, and Laura and I have to sit down to think about it a bit more, but similarly, high potash or mixed alkali glazes seem to be like that, and there is a long prehistory because even the Jaipur blue is only a 17th, 18th century product. We have stuff from the 14th century where there's trichrome ones with the underglaze, the painting, the white base, all the things that Maninder is describing, a kind of a prehistory, both on frit and on terracotta. And then there's all kinds of complexity about blue, a copper-based blue, a cobalt-based blue, different kinds of cobalt. So I'll give you an answer in a year. Yep. Bhuvan. Yeah.
Regarding glaze, these all glaze that we have, that Maninder and this paper talked about is all medieval glaze. But we have glazed ware in Kushan period also. There are certain glaze styles which were reported from Mathura. And then at Aichatra also we have green glaze on pottery, as well as the plain, simple, translucent glaze on pottery as well. And after that, we have bricks with blue glaze on them during the Gupta period, that is around 4th century AD. So there is a tradition of blue glaze and green glaze and the common translucent glaze on redware in very early times, starting from Kushan period, that is around 1st century AD, and at least we have got evidence up to 4th, 5th century AD of the jade blue glaze that is there, which still is. I'm asking Maninder to do the additional work on them. Thank you. Yes. Yes, I'll be. You are the right person to take the call. Even if that, that's why I've Maninder to help me in this, and Sidharth also.
At the back there.
Yeah, this is to Ritvik. You did make a mention of Telgezer and the torpedo jars in connection with South India.
Yeah.
Was it related to bitumen or any other connection that you were able to establish between Telgezer and South India?
Telgezer, I didn't mention that.
It was there in your...
Yeah, but I mentioned Uruk. That was mostly Jamdat Nasr and Uruk.
So what was the reason for mentioning Telgezer that I was...
Those are also, actually the analysis that you have there, that is taken from Hill and Glasscock. So they have done some analysis for material from Iran. So we tried to superimpose our results onto that and try to compare, because we couldn't get the samples from that area. So we tried to take some, samples and actually compare with that. So that's why you have Telgezer and everything that is put up there.
Okay.
Further questions, especially from the students, perhaps to draw upon the extensive experience of Professor Krishnan, who is here. When I was a student, I would have died to have a chance to ask him a question. Questions for Sidharth?
Hello, sir. Sir, I have a question. As you mentioned, NBP, Sidharth, sir, as you mentioned, NBPW pottery goes from 2 stages firing. One is closed kiln firing and second is open firing. So, sir, when we fire in pottery in closed kiln, we will get black pottery. So, how it apply on NBP pottery to get that much polish as NBPW known is?
As we saw in our results, that outer layer is completely fused. Means there is a kind of sintering that is responsible for glaze. And inner part of the pottery and outer part of the pottery both are black. So we assumed that this is fired in such a way that earlier temperature was low and low for a long time, and then they created a big amount of temperature. So transferring pottery from one kiln to another kiln is a difficult task. So we also conducted some experiment on this. So it is assumed that these pottery were arranged in closed firing pit, and then with some fuel and flushes also, and fired. In reducing atmosphere, when it was fired, it turned into black, and when we opened outer part of our kiln, temperature suddenly exceeded, and that temperature I think reached around 1100 degrees centigrade, 1200 degrees centigrade for some time. And at that point, glaze appeared. At that temperature, outer layer fused and sintering occurred. That was the responsible for.
Sir, but in second firing, oxidization process will continue.
Yeah.
So it will change into some gray or black to gray or red. Something?
No. If temperature sudden rise, it will not change into another color. Only because temperature is high, that will turn into glaze, in glaze layer.
Okay, sir. Thank you.
Other questions? While people are thinking of questions, I will ask Professor Krishnan a question myself. If I could ask you, sir, could you talk to the students about, say, to any of the students in the room who are in charge of the ceramic assemblage or in charge of analyzing a particular ware at any site, how should they think about how to approach a petrographer? And what are the things they should be thinking about while they are doing the preliminary analysis in the field?
If I understand your question correctly, may I repeat the question? At what stage of your ceramic analysis you should approach a petrographer, correct?
And with what preparation? And with what preparation?
And with what preparation? Okay, good. From my experience, let me tell you, people have been approaching me with ceramic samples and asking me to study that. So there I did not know what I was supposed to do. So what I did was, generally I did a fabric characterization for them and tried to make an interpretation out of it. But if you really want to take the help of a petrographer, you should have a problem that would only a petrographic work can resolve it, for which the sampling strategy has to be different. For each kind of problem, there is a separate sampling strategy. And I am cooking up a story here, okay? Suppose you have a very good, very fine ware, which is very less in quantity, coming from a specific level of an archaeological site. And you are assuming that that has come from a distant trade or something of that sort. In such a case, what you have to do is that you do not have the raw material with you from where this particular pottery was made. You only have this pottery. So you can make an assumption that the coarsewares of that particular region, which is in high quantity, statistically, which is in very high quantity, is representing the local geology. And the mineralogy that you are going to see, it will be the local one. So therefore, you have to give, if you are taking 10 samples of this particular fine wares from his collection, you will have to have same number of 20 or 25 reference samples of that coarsewares, with which you can compare and see if there is any kind of variation or difference. So now that is how it has to be handled. That is one occasion. Now, do you have any any second kind of context, if you can?
What if we wanted to understand, say, cooking jars and other kinds of storage vessels, differences between the
Cooking jars and storage vessels, how does one understand the difference between that? First of all, it is shape, the form. Storage vessel would be very big and all those things. And cooking jars actually quite small, means maybe something around 15 or 20 centimeter tall, and probably the mouth would be something around 10 to 12 centimeter wide, and the middle portion would be something around 25 centimeter wide. And it will have a rounded base. So that is the typology of it. Whereas in case of storage jars, you will have There are varieties with rounded base, varieties with pointed ones, different types. But in the pointed ones and those rounded ones, you have the jar stands. Actually, some of the jar stands that are exhibited outside, it has a different label, but they are the jar stands which are kept outside from that megalithic sites. The label is a bit different there. So such kind of stands are there where you can keep the vessels. Now, that is so. One thing is from the typology. Second one, I have not come across anything with any kind of soot marks or anything like that. But there are certain kind of studies that have been done on the composition of these cooking vessels as well as the storage vessels. The cooking vessels do contain minerals whose coefficient of expansion is very close to that of clay, because they are very frequently heated, twice a day sometimes, or sometimes 3 times a day, as a result of which the thermal shock, there should be some material that are resistant to thermal shock. And you will find it, calcite is one of them, feldspar is one of them, and calcite, then basalt rock fragments. So there are certain materials whose coefficient of expansion is very close to that of the coefficient of expansion of clay. So that will act as a thermal shock resistant, and that is a second one. There are 2. Did I pass the exam?
I think the coefficient of expansion of all our hunger is increasing. So it's my pleasure to say that we can go to lunch and continue the conversation there. I will encourage all the students to approach the 5 speakers because there are a wealth of information, all kinds of new insights were at stake. One very important announcement. We are going to, talking about expansion, we are going to contract the program a little bit. So we will all assemble back here promptly at 2 p.m. so that we can then have the next session and everyone can attend the valedictory session. So lunch right now, everyone back in the room by 1:55 to 2. Oh, sorry, wait 1 second. Yes, one.
I want to say something to our students. Whatever we do with pottery is considered as archaeometry, right? So, what can we do in archaeometry? Especially if we see some literature like one of my guru, M.S. Type. What can we get from ceramics? What kind of information we can get from ceramics? So, he basically defined that we can know about manufacturing technology. We can get information about provenance pottery and how those pottery were used in life. Also, we can get some information about discard mechanism or how we throw those pottery from these analyses. First, you need to formulate a question about what kind of analysis you want to do on particular pottery. What is the problem associated with pottery? And there are several techniques, a wide range of techniques available for archaeometric studies. So first you understand the background of pottery and what problem is associated, what you want to know. And if you'd be able to know what kind of data you want to generate, what kind of information do you want to obtain from your pottery, then only after you decide which instrument you want to use or how would you conduct your further analysis. For further analysis,
Thank you,
you can
Sidharth.
contact anybody and we can guide you. Thank you.
I have one further announcement that I've just been informed about. If we witnessed the Nizamabad potter setting up the kiln, there is apparently a crucial mid-firing procedure that I do not know the details of, but we should go right over there right now, witness that, come back, eat your lunch fast, and 1:55.
थोड़ा सा हाथ ऊपर जाना चाहिए, क्योंकि जहाँ रहेगा तो आप करिए।
अच्छा, ऐसे
ये देखिए सर, इसमें 3 उंगली डाल के
थैंक यू भैया। हाँ तो बहुत बड़ी चीज़ होती है करने। जी जी,
आज लगातार जब हाथ लगाएंगे 2-4-10 दिन तो अपने आप अनुभव होगा इधर क्या करना है।
अच्छा, ये बढ़िया, ये जो आपका है ना, ये बड़ा स्टेबल है। जी सर, है ना। हाँ, वो चक्का वाला वॉबल भी करता है। ये बन गया, और इसलिए डिफॉर्मिटी।
हमारे हम लोग नगर पंचायत में हैं,
ऐसे वाले लाइन जैसे
यहाँ पर 8 किलोमीटर दूर से आता है। माने एक ही तालाब तो काला पकाया जाता है, पकाएंगे तो टेराकोटा हो जाएगा। बन का वो अलग मिट्टी है, पत्थर और टेम्परेचर दिया जाता है ना, पक जाता है, फिर उसका टेम्परेचर डाउन होता है तो उसमें धुआं पैदा होता है। ऐसे तो पत्थर वाले चाय का काम करते हैं, वहाँ जाकर बैठ गया। अभी तो 25-30 साल का है। अंगूठे से प्लेट डालिए, ऐसे बैलेंस बनाइए, जरा आप घुमाएंगे तो your nails will give you some different textures. Tell him that you can use it beautifully.
This is my colleague, Dr. assistant professor, and again a Deccan College product. Don't forget to only to your old Deccan College remains different than the rest. And she is going to explain you what it is.
Making the vessels, and maybe tomorrow this firewood was also transported from Nagaland, so they make a small temporary kiln and they show you how the process of fire.
Tana, phone. Countable is this. They rotate it while working. Just see look at this.
person name in the box.
Show the camera. Okay. நான் இருக்கும்போது யாரும் மதிக்க மாட்டாங்க. தெரியல, கேமரா தெரியல, கொஞ்சம் கேமரா. ஓகே. ஓகே, எழுதுங்க. அப்படியே கேமரா ஃபேஸ் பண்ணுவோம். அப்படியே கேமரா நீட்டு காமிங்க. கேமரா காமிங்க. ஓகே. தேங்க்யூ.
Why you want to give to your husband? No. For whom are you getting it done? For yourself. Go. Okay.
Hello, am I audible? Shall we start now the post-lunch session? I suppose we are. Shall we wait for 2 minutes, or Alok, shall we directly start? Announce the presenter's name. This is the 8th session of this seminar. The theme is pyrotechnology, and we have 3 speakers. And our first speaker is Ekaterina Girchenkov and Oleg Kardash. They will actually be presenting on chemical technological analysis of the Lai people ceramic of Hainan Island, the problem of preserving pottery traditions. May I invite the 2 presenters to come at the stage? Yes, thank you.
Dear colleagues, we are probably the most northern participants of this conference, and it's a great honor for us to take part in this wonderful event. So many thanks to all the organizers, and I'm very happy because it's nearly about 60 degrees warmer than it is now at my place. So let us start. Our laboratory investigates mostly different aspects of archaeology and ethnography of the north of Western Siberia, which is in a local Hanty language is called Yugra. That's why it is named the Yugra Laboratory. It is in Surgut city, which is located, well, more or less in the center of the northern Eurasia. So our main goals are to investigate and to preserve the historical and cultural heritage of ancient and traditional societies of northern Eurasia. So we have several permanent expeditions, mainly in the north of Eurasia, in the far north. We are working with a frozen cultural layer. So also many of our works are concentrated around making three-dimensional models of different constructions of that had been excavated during our excavations, both of ancient times, of Middle Ages, and well, for example, this one is the most ancient Neolithic site of northern Siberia, which is a kind of earth wooden construction. And during the last 4 years, we have been building it to life size using only Neolithic tools. And of course, one of the most important area of our research is studying the migrations and the spread of ceramics production technologies from ancient Neolithic centers in the eastern Eurasia to the north. So of course, we know that the earliest pottery sites are located in northern China, in Japan, and the Russian Far East, and they're dated back, well, probably some around the 14th, the 10th millennium BC, and the earliest ceramics so far comes from Xianzhendun cave in southern China. And in the north of Western Siberia, the earliest ceramics dates back to around the 7th, the 6th millennium BC. So it is much later, but they are actually very similar to early examples known from the East, both in form and in ornamentation, and which suggests that, well, probably there was a stable tradition that has been preserved with the migrations despite thousands of kilometers, thousands of years, so it looks just absolutely the same. And so, well, for example, if we try to compare it with Jomon ceramics of Japan, so the earliest one, once large flat-bottomed vessels, sometimes with a belt of pitting impressions. We have absolutely the same ones, but actually they're much younger, of course. And this form is still widely used in ethnography, but actually not for cooking, but to preserve the animal fat in a liquid state necessary to maintain the fire. And actually, in the north, we often use ethnographic materials for comparative studies and for reconstructions, just because, well, people who lived in relative isolation for many centuries have preserved both architecture and material culture practically unchanged. And when we want to investigate the migrations to the north and the initial points of ceramic technology migrations, we want to study the culture of other peoples living in the East Asia who have preserved relict features of ceramics production and who tend to live separately away from agricultural societies. So we chose Li people because, well, it is the southern China where the ancient pretty similar ceramics was found, and also because right until the 1950s, Chinese control over the mountains regions of Hainan was relatively nominal. So the potters who we worked with, and they are now about 80, 90 years old, they lived in Ujishan mountains before the villages were relocated. And that fact allowed them to preserve many ancient traditions up to the present day. So these investigations involve pottery makers from Donghe village. It's the Dongfang County. It's the east of the island where they live now, because there was a government relocation program which was aimed to create more comfortable living conditions for indigenous peoples. And they actually didn't want to go to live somewhere else, but still, well, this company started, so they had nothing to do. And, well, a bit of history. There's a little video fragment where we can show you where was the initial point of their living. Right now, it's over there. It's pretty slow. No, doesn't go any further. Okay, then. Well, so the Li people, self-named Hlai or Sai, are the indigenous population of the Hainan island, the southernmost province of China. So the earliest mentions in Chinese chronicles say that the Li people were the highlanders that came from northern and central Vietnam. The active development of the island by the Chinese people, by the Han population, began in the Tang dynasty period, so it's about the 7th till the 10th centuries. Chinese migrants, they usually settled mainly in the coastal area, and Li people gradually moved into the mountains. So the contacts between two peoples were pretty rare, mainly based on the barter trade. Li also learned from the Chinese the basics of agriculture and the irrigation, but their living conditions did not allow the skills to be fully used. The Li were rebellious. Actually, they did not want to pay any tolls, so there were military campaigns against them in the Middle Ages, but they usually ended in failure for the Chinese. So since Li people could better navigate in the mountains and the impassable Ujishan, Limushan mountains, so most of the time they were covered in fog, so they were like impenetrable fortresses, something like that. So up until the 1950s, there was almost no control over the mountains of Hainan. And according to the modern data, the Li people are about 1,600,000 people, and which is equal about 15% of the island population. So the Li people we worked with, they were relocated from their original places of residence, which is on the slide, in the 80s. And this village, by Chatsun, consisted of several houses with thatched roofs, quite far from where the Chinese people lived. So even now, when we wanted to find the driver, many drivers refused to go there with us, saying there was no road, but actually there was one. And now the village is empty, and well, there should have been an ethnographical village, but it is pretty far from touristic places, touristic routes, so it's pretty hard to get. So right now, Li, who lived there before, come and keep the village in a good condition. So the hereditary potters from the Donghe village are mostly women, as I said. They're aged about 80, 90 years old. There are no younger potters in the village, and actually nowadays, when the borders between modern and traditional culture are gradually blurring, potters worry that their resettlement to larger populated areas where the Han people are the majority will gradually lead to an ability to find a convenient place for folk crafts, and homemade ceramics will eventually disappear. And despite the new living conditions, the respondents try to save the pottery traditions inherited from their ancestors and do not use modern metal, plastic tools, containers in their ceramic productions, since any violations of established rules can lead to negative consequences. And craftswomen prefer to independently make the necessary attributes from bamboo, from wood, from shells. Well, the Neolithic archaeology of Hainan Island has not been studied deeply enough and includes only a few investigated sites with ceramics. Li people do not have a written language, so therefore there are no sources recording the history, the development of ceramic production, but nevertheless, archaeological materials indicate a 6,000-year history of ceramics in Hainan. So the first written mentions of Li pottery take us back to the Song Dynasty. These are chronicles of Zhao Zhugua. He was a geographer, but actually there is no much information about pottery production, so this one is the one that is above. This is from Song Dynasty, then from Qin Dynasty. This is the 18th, the 19th century. Also, not much information. And Shi Dubo is the anthropologist of the 20th century. And probably that's actually it, nothing more. And well, pottery making is a women's craft. The gender orientation of pottery making, when the skill was passed down only through the female line, from mother to daughter, from mother-in-law to daughter-in-law, is also recorded in later Chinese written sources. It was stated then that women were engaged in productions of dishes and men were involved in the sales of finished products. And barter trade is still preserved in small settlements and even considered preferable because it's some kind of a tribute to the behests of the ancestors. And the rules for traditional exchange usually depend on the pot volume. So you can exchange a cauldron, for example, for the amount of the shanlan rice equal to the volume of the cauldron itself. And the purchaser first fills the pot with rice and then pours it into the sales basket. So we used the historical and cultural approach as a methodological basis for this investigation, and as a part of our field work as a Donghe village, we traced and recorded all the stages of pottery productions. Kaolin clays, common in Hainan, are very suitable for modeling, do not require any additives, and it is usually an orange clay with white inclusions, which was formed as a result of 20,000 years of physical wearing of rocks. And potters collected in ravines near the village, and their ancestors also collected material there, and the depth could be up to 4 meters deep. Respondents claim that during the process of collecting, they smell and taste the clay to determine its suitability, and the taste of clays changes due to the depth or if there are some organic impurities or not. And actually, what is really interesting that our chemical analysis show that there are differences between the samples selected by the potters as suitable and those which were rejected as is unsuitable. So that's very interesting. They just tried it by taste and said, well, this one are not suitable. Color is also an important selection criteria. So they say that, well, usually they say that 4 selection criteria are being used: by eye, by touch, by taste, and by smell. So the selected clay is dried in an open space for about from 5 to 7 days. The Li potters of the Donghe village use a hollow tree trunk for these purposes, and after the clay is dry enough, it is crushed in a wooden mortar and sifted in homemade sieves with different hole diameters. So water is added, but not much. Not other additives or organic solutions. They are but they are quite rarely being used. And the vessel, so these are the sieves, homemade sieves. Everything you can see is made by these craftswomen. And just to brighten my presentation, there's a small video fragment.
它就是要它水来合成泥的嘛，就这个泥状嘛，捏。骨是成型一块块，你得有太阳。thang là châu cũng đơn muôn đơn kêu cho cờ cho không đơn cho cũng
không có phun nào mà này về bản tôi cho ấp hai cho hư mà hư chủ biên đông mang rơi đấy mà
跟你带那个来也是，黎族做的也不一样，它海南有黎族的地方是也是很辛苦的一个过程。
Пошел процесс.
Con lấy bài luôn ủi ra hơn.
Con ở vùng này nó có trước kì. 就可以
回来了，这种是能够做得好的，
Yeah. So as you can see, they are just putting bands onto a round base. They know spiral molding from coils forming both the walls and the bottom, but actually they prefer this one. And so the construction of the hollow body begins with rolling the clay into long ropes, depending on the type and size of the vessels. And the next step is smoothing the joints, beating the surface with a flat spatula, removing defects mainly with seashells, wood, and bamboo tools. And as they claim, this is one of the most archaic forms of pottery productions that survives today, using simple tools without the use of the potter wheel. So the rim is always formed from a separate coil placed on the top of the outer edge of the vessels, and potter achieves the desired shape using various types of bamboo knives. There are just a lot of them. And so before drying, the finished ceramics products are left to dry in the shade for 6 or 8 days. So here you can see bamboo knives and shells that are being used, and these vessels are being dried. And the size of the fire pit is determined by the amount of ceramics being fired. It should be an open place for at least about 10 square meters. It should be away from residential buildings. So the large containers are placed first, forming a circle. Small ones are placed in the center. And it is necessary to maintain the distance between the objects. And sometimes the base is made up of 4 stones. Branches are laid on them, and then the ceramics is placed upside down. So the entire structure is covered with a thick layer of straw, sometimes coconut shells, which is an additional fuel, and the firing time ranges from 1 to 3 or 4 hours. And when 2/3 of wood has been burned down, the pottery has changed color, the additional straw is being put on the burning pile, and so the vessels are situated inside a thick layer of ash, which has good insulting properties. And after firing, the readiness of a vessel is checked by slight knocks on the surface, and it should sound clear and ringing. What is interesting more, all the technological stages should be followed by mandatory rules, rituals, without which a good product could not be made. For example, potters usually choose a gloomy day to collect raw materials because it is believed that on rainy days the mountains gods sleep and they won't be ever disturbed by clay mining. Or, for example, if during a prayer to the gods any sound is being heard, for example, thunder or an animal growl, then the potters consider this as a sign from the gods that they are preventing the extraction of clay on that day. And on the day of firing, on the contrary, there should be no rain, no typhoon, because this indicates that the gods are angry. There should be no funerals in the village. It is believed that lighting a fire on that day can attract unclear spirits. And if the fire could not be lit immediately, then there is a sacrifice to the gods, usually in the form of chicken, and a prayer to the gods to expel the evil spirit from the fire. And also during the pottery firing process, men are prohibited to be near the fire. It is believed that the vessel can be split because the male yang, strong energy and power can cause the fire to be hotter and increase the temperature. That's why. And here is the firing process in an open air. One more fragment.
riêng là đến đây nó phụ nữ dâu nó cứ đến xem thâu.
他说拿这个锅出来之后，再要水来拍打，是吧？
这个是树皮的。
Yeah, and the last part of the process is also very interesting. Just as you can see, when the firing process is almost complete and the fire gradually goes out, the potter, using a long wooden stick, pulls out the hot pottery vessels and immediately sprays it with the dark red sap of a bark. This is, okay, right, like it is seen over here. So this is the Huayin tree, and actually, according to experimental analysis, the bark sap contains relatively high level of metallic chemical elements such as copper, iron, magnesium, zinc, potassium, sodium. Well, and this multi-spot pottery is very, very popular among the Li people who believe that it brings luck and blessing to the owner with many children. This is also associated with the cult of the frog, so the symbol of the female world and in aid in achieving family happiness for those who subsequently buy these ceramics. So the spots on the surface symbolize eggs, frog eggs, so the signs of future numerous descendants. And actually frogs are very important. They take a very important place in Li people mythology. Yeah, and so these vessels are ready for sale, and all of them have these spots, red spots. Okay, and just a few words about chemistry, because the chemical investigations are still in progress. But we have some small initial details that we can present for you. So 8 samples of clays and ceramics were chosen to study the structure, the mineral composition, the chemical properties of clay minerals. And it is really interesting that our spectral data, which allows us to estimate the firing temperature of ceramics, showed that this ceramics was fired at a temperature of more than 500 degrees Celsius. That's pretty interesting that we know that the firing was carried out in an oxidizing environment, but the chemical technological analysis showed that it seems to be the reduction firing. So that means that the potters could achieve subsequently high temperatures, and the parameters of reduction firing for ceramics in an open fire. Perhaps it could be connected with the properties of clays, high content of hematite, long-term drying of the product before firing, or the constructions of the fire pit, structures made of branches, straw, coconut shells, so at the final stage in a dense layer of ash. So in a short time, potters could reach temperatures above 800 degrees Celsius and obtain vessels that just looks like it was fired in a closed kiln. And oh yeah, that's why. And also we also got the elemental composition found by X-ray phase analysis. Well, showed that the main components of the clays were oxide of silicon, aluminum, iron, potassium. So this probably pretty unique because, well, for example, some samples exceed the amount of other metals, including rare earth metals, in 2 or more times. So it can be explained by the peculiarities of chemical composition of clay minerals of Hainan Island. So that's we should take a look at it more because, well, it's pretty unique, really. So these are the results. So what we can see here now, so the selection of raw materials. So informant, they say that selection criteria based on empirical experiments, so they taste it and they choose only light colored orange clay materials, and it's usually lays very deep. And 8 samples were chosen for chemical research, and 1 of them was unsuitable, and actually the potters said without any chemistry, they said that yes, this one is not suitable. So and when we got the chemical research results, so it showed that yes, it differs, not much, but still. And what more, another interesting point about firing, that they could get very high temperatures in an open fire pit. So that's also very interesting. Well, we didn't say to our chemists that it was an open fire, but they said, oh, it was a kiln. But that's really interesting also. And also ornamentation. So people usually say that the ceramics of Li people is not ornamented, but as we can see, the vegetable sap, the Huayin tree sap, is connected with traditional mythology. So that's also pretty interesting. And also we are now in progress of SEM analysis, so there are some pictures, but it's not ready yet. So maybe next time at the next conference we will show more chemical research results. Yeah, and many thanks to all the Donghe villagers who helped us. And thank you for your attention.
Thank you, Ekaterina, for that excellent presentation on live people ceramics. I think we will keep the question-answer discussion session for all the 3 papers at the end of this session. The next next paper is on more ideas on Harappan stoneware bangles by Massimo Vidale.
So, here we go. So thanks a lot for being here. And I decided to take the chance to present in this important conference a kind of state of art about what we know, what has been done so far on these fascinating Harappan artifacts that are very, poorly known from many points of view. And the problem with this product is that what has been published so far has been scattered in a kind of gray literature, which is not always very easy to access. So, okay, we can go on. I will show materials which depend to a great extent on what we have been doing in Pakistan, in Mohenjo-daro in the 80s, and then integrated by the research by the colleagues of the Harappa team. So I will also use some evidence, pictures, and results of the Harappa research project. Okay, so I don't know how many of you are aware of this particular seal. This was smuggled out of the country, probably out of Pakistan, and then sold for 60,000 pounds. The reason why in England, the reason why I show it just to repeat how important were bangles also on a ritual level in the iconography and probably in the daily ritual lives of Harappan people. You see the so-called Lord of the Animals with the arms completely covered by bangles, and also the two female personages with the peacock feather behind their head had their arms completely covered with bangles. We don't know if these were stoneware bangles, they could have been shell bangles or whatever. Okay, so stoneware. What is stoneware? Stoneware refers to a highly levigated ceramic without pores or with very little pores and inclusions, fired to temperature which should not have been very far from 1000 degrees, reaching a point of sintering of the ceramic body. They are present in two varieties. One is gray to black, the other one is red to orange, and usually the gray to black are the most sintered one and the finer one, at least at Mohenjo-daro. The fracture surfaces are conchoidal, like what you see on flint. Whenever I show the few fragments which are still with me of the stoneware bangles to a geologist, he says it is not pottery, it is flint. And the X-ray patterns of this material show almost exclusively newly formed minerals, mostly of anorthitic types, like a plagioclase. Okay, this is a map of Mohenjo-daro, and what you see on the southeastern part of the city is the part of the city that, like has been observed at Harappa, is more rich in evidence of craft activities. So this pattern, in a way, links Harappa and Mohenjo-daro. I've been working for a long time in this part of the city, between 81 and 92, and the areas, AA means activity areas, that you see marked on the map are the two probably workshop areas where two large installations for making stoneware bangles were found. Okay, these are the bangles. You see the gray variety on the left and the red-orange variety on the right. And these are new pictures that I take just to show you the extreme homogeneity and the compactness of the ceramic body. See the conchoidal fractures. And on the right, you can see the thin, parallel, very regular lines which are distinguishing these bangles. See how perfect is this ceramic product. Most probably it is the most refined and complex ceramic product of the 3rd millennium BC of the early Bronze Age. So you see that there is a different surface, and what you see here is part of the bottom of the clay sagar or clay box in which the stoneware bangles were fired. They were fired in closed containers, somehow like you have seen outside during the demonstration of the potters, but in a much more refined and controlled way. The same fragment of bangle from a different orientation. So on the bottom you see part of the refractory box in which this bangle was fired, and clearly the firing process went wrong. the box was melted down, everything collapsed, and the product were thrown away. On top, you see part of another stoneware bangle, which was stuck in a kind of column of 2 or 3 bangles, and when all the thing was partially melted and broken, retained part of the upper bangle. Now, these are old X-ray diffractions that we did many years ago. We are running now new analysis with a semi-quantitative system, and on the right you have the thin section. So on top you have the section of the saggar of the container. You see it is coarser. And here below you have a thin section of the gray variety and of the red variety. And basically what you see with the X-ray diffraction pattern is anorthitic plagioclase, traces of cristobalite, which is the high temperature phase of quartz, forming, in our case, probably around 1,000 or slightly more, magnetite, and diopside, which is another neoformed mineral which forms at high temperatures, okay? Now, just to show you the composition of these bangles, this is a high-resolution ICM image. You see there are no porosities, everything is highly sintered, and you see some crystals in a glassy matrix. The crystals are very small. We are speaking of crystals forming with sizes which vary from 2 to 5 microns. And the different phases are shown in these pictures. You have a glassy matrix, which is the gray part, and then crystals of anorthite, a plagioclase, and a pyroxene, another high temperature mineral, which has been identified in this case as fascite. And the white little spots that you see here are the iron oxide, magnetite. And if you look at the scale, you see the dimension of these particles, but we will work on this. Now, note other features of these bangles. So the section tends to be subtriangular or egg-shaped, and you see that the quality of the ceramic paste is not always so fine. We have a kind of gradation from coarser specimens to very well levigated, extremely fine specimens. And then we can go to the archaeological feature, which is most impressive of this bangle, the micro-inscriptions. I have calculated that 1 fragment of stoneware bangles out of 5 has an inscription. And because they usually break in 5 or 6 fragments, my impression is that every bangle was actually inscribed, okay? These inscriptions are usually shorter. The one you see on the lower right is the longest one, we know. And they are extremely fine. Here you see other examples. So these bangles were so important that each one was marked with an inscription. And this is a picture that Mark made, if I am not wrong. And you can see how small are the inscriptions. No more than 2-3 millimeters, and the point is probably 0.3-0.4 millimeters in width. And Asco Parpola had noted that there is a certain frequency of the double circle sign in this inscription, and he thought that this was also referring somehow to the bangles, and proposed some interpretation of this coincidence. This is the bangle that we have seen already, the only one we have which is painted instead of being inscribed, and on the inside instead of being inscribed on the outside. Now, we did in the past a kind of chemical analysis with Jim Blackman, okay, at the Smithsonian Institution while I was working there. You see how neatly separated are the materials, the ceramic materials from Harappa, from those of Mohenjo-Daro. The Mohenjo-Daro chemical group was made by analyzing bricks and kiln linings together with the bangles. So basically the clay is the same. The difference is in the kind of re-elaboration, decantation, and the refinement of the clay that was used. And when the chemical composition of the bangles found at Harappa were compared with those of Mohenjo-Daro, what we see is that the Harappa group is very homogeneous, while the Mohenjo-Daro group contains both bangles from Mohenjo-Daro and Harappa. This means that some bangles from Mohenjo-Daro were found in the collection of Harappa. We should not speculate too much on this evidence because it was based only on 22 bangles. And we were ready to run other samples, but unfortunately, the person who was in charge of more samples somehow disconnected from research, and it was not possible to continue on this line of evidence. But now I take you to another site for a moment, okay? The site of Lakinjo-Daro. Lakinjo-Daro is a big Indus site, not far from Mohenjo-Daro. It is, you know, found in the periphery of Sakar. Unfortunately, the site is not very well protected, and it is constantly damaged and covered by a large industrial neighborhood. The reason why I speak of Lakinjo-Daro is that we published recently in an excellent journal some finds which were found during a small test ranch in Lakinjo-Daro. This is one of the few copper figurines that we know for the Indus, showing a man which, he could be a dancer or a spear thrower, so it is not known. The figurine is unfinished. And near the figurine there was a bag probably full of metal scraps, probably collected in order to be recycled. I show you some of these, the objects which were documented there. These objects include this kind of hook-like thing. We don't know what it is, but the only comparison is with Harappa. And also this kind of, I don't know what these things are, but they are some kind of tablets with a semicircular section, and they have some signs in relief. Usually things of this kind are common at Harappa. They were never found at Mohenjo-Daro. So in this case, we have the contrary. We have objects very close to Mohenjo-Daro that typologically are linked to Harappa and not the contrary. So, the picture of the possible linkages between the two cities is still to be fully elaborated. Now, after the discovery of the workshops in Mohenjo-Daro, both Ken Hoyer and myself started experimenting in various ways, trying to reconstruct the process of manufacturing of these bangles. I was working with a professional potter in Washington, René Altman, and we came independently to the same conclusion. The bangles were made by turning and cutting on the potter's wheel some empty cylinders, which were first found. So you see here, this is the cylinder, and the same conclusion. We did not speak when we did this, but we came exactly in the same direction. You see also in Harappa, Mark decided that the best way for doing the stone-over bangle was turning and cutting an empty cylinder previously made on the potter's wheel. I X-rayed some of these bangles, and I could see the pores inside, which unmistakably, according to me, demonstrated that the manufacture on the potter's wheel. So this should have been the sequence, okay? First making an empty cylinder on the potter's wheel, then cutting the bangles one by one. Mark proposed a flint blade. I would rather suggest a metal blade for reasons which are rather long to discuss. Then the bangles, according to Mark, would have been put on some kind of conical support and then polished one by one. And then what happened then? Then they had to be fired. This is a specimen from Mohenjo-Daro. You see this strange scar here. I believe that, when they were cutting the columns and getting the samples, the blade could oscillate a little bit like this, and this, if the movement was not absolutely steady, would have left a kind of wavering trace from one bangle to the other, and when in a defective process they were trying to separate the bangles, this scar would have been left. Okay. All that we are proposing for the stone-over bangles cannot forget the reconstruction of the faience making process, which is somehow parallel to what I will describe, okay? So this is also another dominion, scientific dominion of Mark and the experience he made in experimental facilities at Harappa. Now, how were the bangles fired? In 1981, I was walking on the surface of one of the activity areas, and I discovered these 8 big vessels just put on a row and eroded to surface in the point which is marked by the yellow arrow. If you remember one of the pots which was showed by Alok, it was exactly the same thing. It was a kind of crucible for making glass, and there was an inner pot which was very solid, grooved, and then an outer layer of chaff-tempered clay slipped in red. So this is very similar to what Alok was describing in a much later context for the making of glass. It is a refractory saggar, a box made for firing something in a kiln. This is the map of the vessels that we found here. They were covered by the collapse of a wall, which was partly in mud bricks and partly in fired bricks, suggesting that the workshop was a kind of makeshift installation, recovering bricks here and there, and not a properly maintained house. Of the saggars, which I was allowed to recover, 2 were completely overfired and almost collapsing, gray, and it was clear that they were all cracked, and from inside you could see that a big pressure had been at work enlarging the vessels while they were sintering and collapsing. The other 6 were red, orange, and fired in a completely different way. Now, I could reconstruct this firing apparatus. So we have here the 2, I don't know if I can use this one. How does it work? Okay, no, forget it. Anyhow, we have an inner grooved vessel, you see, which is solid and substantial. Okay. Sorry for this. It is this this one?
Yeah.
Okay, so here we have the inner pot of the saggar, the outer layer of chaff-tempered clay. These pots were put on a kind of floor of simple terracotta bangles, very rough, but set in a very regular way, as we shall see later. Then there was a lid. This lid, strangely enough, was supported by these 3 ledges. Sorry? Microphone. Okay, you see these 3 supports. These are made with terracotta bangles, which were broken and fixed with some, clay cones under the mouth of the pot, a very strange solution. The lid was handmade, and the diameter of the lid was not enough to cover the rim. It would have fallen, and it was only supported by these 3 ledges here. And then everything was covered again with a layer of chaff-tempered clay, and finally sealed with a unicorn stamp seal. This is the only direct evidence of a administrative, bureaucratic control on a specialized craft that we have for the whole southern Eurasia. And here you have the details of the small fragment of bangles and their supporting cones that were found still sticking here under the mouth of the vessel. Now, you will not believe me, but I thought about this detail for 40 years, trying to figure out which was the sense of this. Okay, here you see the 3 ledges. Now, this is how we could reconstruct the terracotta bangles piles apparatus from the imprints they left on the 2 overfired saggars. And so it was possible, you see, to define precisely here the number of bangles which left the imprints all around. So it was like a radial system supporting this saggar from and separating it efficiently from the floor of the kiln. And this, you see here how only 2 bangles were put exactly in the center. They stuck with a film of 3-4 millimeters, no more, of clay, which was put on the floor of the kiln. Okay, this is the reconstruction. Obviously, while it was collapsing, some of the bangles moved. Okay, so now, this is the geoarchaeological map we made, and the extent of the Stoneware Bangles workshop in one of the 2 areas should have been something like this. And in this area, probably we had the remnants of the kilns used for firing the saggars. We excavated part of this surface. We were not allowed to go deeper than 5 centimeters. So these were our restrictions. But still, we found bangles, we found the leads, we found fragments of the sagars, we found fragments of the perforated floor that you see here, and even the melting clay which was applied within the holes and making this kind of oval stalactites, and a lot of warped, deformed, overfired terracotta bangles. Which type of kilns they had, it was not possible to define. Everything was eroded on surface. This is the map we made. Probably we have the possibility that they were using some kind of rectangular kilns, maybe 3 by 1.5 meter or 3 by 2, something like this. But I would not be so confident to say that this can be taken as really recognized kilns. But they were certainly wide firing infrastructures. I don't know if with the permission of going deeper, we would have been able to get a better reconstruction of this kiln, but probably we had at least 2 different firing infrastructure on the most elevated part of what was probably the courtyard of the workshop. In order to understand something more, we excavated microstratigraphically the interior of the sagars, and what we found possibly some fragments of the leads, fragments of the supporting cones, and what basically we had was the evolution of the local slope from the first collapse to the period in which all the mud bricks around were melting and filling the pots with silt. So this was not very informative, but for the earliest layer, which compositionally expressed the kind of sediment which was moving, I would say, in the courtyard of the lab. This is the primary collapse, and this is the slow filling of the pots. Okay, now, these were the big sagars, but in the other activity area, we had evidence of, no, I am going back, okay, of another type of container, these small cylindrical boxes, which were probably stockpiled one above the other, keeping the bangles inside. Okay, so in this other site, we got evidence of these smaller boxes. This is exactly the trace which we should join to this one. And you see how the stone bangles were stuck. One within the other, one above the other, and within these cylindrical boxes. Note that also the cylindrical boxes were covered with chaff-tempered clay. So what was the relationship between the big sagars and the small ones? These are part of the bangles we found. You see many were broken, retaining the part of the bottom of the sagar. Some sagars were simply superimposed one above the other. Some had each one their own lid. And some of the lids were again inscribed with some signs on the chaff-tempered layer. Now the solution came when I found this big you see, slug. Here you see one box with 2 bangles. This is the bottom, and this is a fragment of the lid, and here another one started. So here the whole kiln collapsed, melted down, everything became soft. And what you see here, these are the remnants of the big sagars, okay? This is a kind of matrix, stratigraphic matrix. So the solution was that the columns with the superimposed cylindrical boxes were put inside the big ones, and everything was sealed. So you can now imagine the level of complexity. Huh? And at the end, everything was closed with unicorn seal stamps. Here we go, and Ascoparpola suggests that the other part of the inscription should have been like this, because this is known from Cianudaro, this type of short text, okay? So this is the final reconstruction of the whole system. We have the bedrock starting from below. You have the basal system with the columns of terracotta bangles. We have the outer chaff tempered clay layer with a grooved vessel, and then the column of the boxes, again covered with the chaff-tempered clay, the bangles inside, and then we go back to the 3 mysterious ledges here, the small lid and the final covering. This means that for firing, in this case, 10 bangles, they had to assemble something like 70, 75 different individual clay objects. Okay, so here you see three-dimensionally the general reconstruction. So we were discussing about the possibility of identifying local production of, red polish wares, black, highly refined pottery like NBP and so on. In reality, when you look for production centers, you should look for something like this. This is a Roman kiln for firing the Aretina ware, and this kind of highly refined pottery, luxury product. And what they did was to start fire here, then conveying the fire in the combustion chamber here. This is the perforated floor. But the gases of combustion, they don't touch the final product, never. They go into these tubes in different floors and so on, so that there is no contact between the irregular fumes and fires of the kiln and the product to be fired. And the concept is probably the same for Harappan stuff. These are the experiments of Mark. Mark was able to reproduce the canisters, and then he put inside the canister the boxes, and then he filled everything with animal dung in the attempt of obtaining highly reduced conditions of firing. Then I don't know if this was the only experiment by Mark. I think this was partially successful, but then one of the box broke, and so the bangles became in this particular. I have only these pictures. Probably Mark has much more information about this. But just to give you an impression of how the system worked, and these were the results. So, okay, I am coming to the end. The problem of the three ledges and the movable lid, under the influence of what Mark did, I suppose that the big sagar was completely filled with animal dung up to here, and also, on top of the lid. When all this system was firing, a lot of gas was probably forming inside, and this is sure because two of my big sagars are completely cracked from the inside, so there was a lot of pressure. This pressure was, meant to lift the lid, pressing it. I mean, this lid, the small lid, you see it is smaller than the mouth, and pressing it against this chaff tempered layer, which might have been working like an osmotic layer, absorbing part of the gas, but at the same time preventing the outer gas to come in. So I think this lid here was movable, and that the pressure of the gas would have pushed strongly the lid against the upper coat of the vessel. In this sense, okay, this system was a pressure release valve of the Bronze Age, and this is what I propose now in terms of history of technology. I also started to wonder whether the control of pressure beside the reduction, beside the temperature, could have been one of the factors allowing this ceramic material to get rid of any pore and get exactly to that precise sintering moment, okay? And this is what we are now trying to figure out with a new set of archaeometric analysis. So in this sense, if we are right, okay, this is Papin. This is the guy who invented the pressure pot in the 18th century in France. And the reason why he wanted to invent the pressure pot is that he wanted to give to the poor people the possibility to eat the meat of rabbits, because rabbits, especially wild rabbits, that the working class people in France in the 18th century were eating, were very, very hard and difficult to chew. So he invented the pressure pot. But I think that, now probably the unicorn came first, and I think it is quite possible that the Indus people had invented the first pressure release valve in the world. Now, let me just add a couple of other sentences. We had read a lot about sphere of interaction technology that brings people together. I am speaking to Mudit, obviously. Everybody's happy, and everybody shares the ideas, and everybody communicates, and so on. These technologies are not like that. These are secret technologies that potters developed in the course of probably centuries. I am sure that the beginning of this technology should be searched for in the Ravi phase and much before. And it was a technology protected by secrets. And this is why probably this technology then at the end was scarcely preserved, I would say, in later technological developments. So do not forget conflicts. People is very bad. Not everybody is so good and happy to collaborate and spread these secrets around, okay? Thank you very much.
Thanks, Professor Massimo, for that very exciting presentation. I'm sure you will have a lot of questions for him. We will have it at the end of the session. I will invite the next presenter on the importance of technical ceramics, archaeometric analysis and historical interpretations of crucibles, furnaces, molds and tewers, and a case study from southern Thailand. Thomas Oliver.
Thank you. Oh, good afternoon, everybody. We're nearly there. Thank you very much to the organizers again. Now, Dr. Kanungo asked me to do something that was going to teach students and also interest scholars. So hopefully I keep everybody happy, but of course I run the risk of upsetting everybody. So firstly, I'm a Southeast Asianist, I'm an archaeometallurgist. So what am I doing here at a South Asian pottery conference? Technical ceramics are implicit to metal production and almost all high temperature technologies, as we've just seen. Metallurgical chaînes opératoires are often dependent upon the technical ceramics which are preserved and actually not on the metal which is gone elsewhere as a product or has been recycled. And we're also using the slag. As a plastic medium, ceramics offer enormous range for the expression of technological style. So yes, your furnaces, your crucibles, etc., have to perform certain tasks, be refractory, strong enough, control the atmosphere, but within that there's a huge range for expression. So not only do we share an interest in clay products, we can investigate relations between potters and artisans from other industries, compare domestic and technical ceramics, or the technical ceramics of glass versus metal versus glazes, etc., etc. Are they using the same pastes? Are they using the same tempers? Are they the same construction techniques within the same society? And if they are similarities, is it because just simple convergence, there's a technical reason, or does everyone use the same temper because that's what signifies our social group? And of course, we're all working towards the common goal of better understanding human lifeways and interactions. So in this presentation, I'll show a range of technical ceramics from around India and Southeast Asia. Now, mostly Southeast Asia, from where I have worked mostly. Of course, India has many fantastic technical ceramics, in particular steel crucibles, which is so relevant down here in the south. But I haven't got pictures of those because I haven't visited them. And whether you find it interesting or not doesn't matter, because this is me talking to the student, not my dear colleagues. You're going to see them. As we have seen in your last presentation, when things melt, it all goes to pot. And that is a joke. Yeah, everything becomes not just sintered or vitrified. We're talking bloated and melted. Everything's red, brown, black, and you can't tell what it is. Then I'll summarize the Southeast Asian protohistoric paradigm. I'll talk about Indian high-tin bronze bowls. And I've put it in quotes because, not because I don't think they're Indian, but because I'm dissatisfied with just calling them Indian. I want a bit more geographical and cultural precision. So as we saw from Professor Bellina's presentation the other day, and also what Dr. Favereau showed us, Professor Bellina talks about beads, high-skilled technologies in bead production, evidencing the movement, or the limited movement, of South Asian artisans to Southeast Asia. I don't argue that, and that's not because I think Professor Berlina's wrong. I just don't think my evidence is as strong as her evidence. You've got to be always very self-critical of what your actual data set says. And then I'll show some archaeometallurgical data, predominantly lead isotope based, for mid-late first millennium BC Trans-Bay of Bengal exchange systems, and where it got blocked. Some of this work is actually about 15 years old. It's got blocked in certain areas, carried on in others, and I hope we'll be able to unblock it together in the coming years. So what are technical ceramics? Well, we've seen a few of them over the course of this week. Pyrotechnical structures, furnaces, kilns, hearths. They can be all sorts of shapes and sizes adapted to the technology of what they're doing, what redox requirements are, what temperatures are. I've heard here people talking about high firing being 800-900 degrees. This is baby temperatures for metallurgists. We're talking 13, 14, 1450 degrees, and we'll melt everything you've got. Tuyers are the air pipes that introduce oxygen into the pyrotechnical structure at the correct angle, pressure, as we mentioned earlier. If you have a very wide bore, that suggests that you've got some sort of powered air delivery system, otherwise you wouldn't get any gas penetration. And sometimes the air's preheated, so you don't get a shock in the furnace. Crucibles, high temperature reaction and melting vessels. Molds, receptacles for casting molten materials. Building materials, we've also seen mentioned here. And if you imagine, we can see how hot a bonfire gets. If you have a house burn, or even a section of a town burn, we'd call that a conflagration. And then you're going to get massive temperatures, and everything's going to be a molten mass. So anything that's got a bit of clay in it and gets heated and or superheated. And all of this could be made in non-ceramic materials or not even present at all. So this is a recent active brass casting workshop in northeast Thailand. So you can see there's a coiled fresh example on the left and then a used one on the right. They've built a spout into it already. It's absolutely jam-packed with rice chaff, and it seems to shrink quite a lot in between the preparation, drying, firing, and use. That's the little hearth they were using them in, so there's actually not a lot of space for fuel around that. This is the discard, just chucking them in the backyard. So I didn't understand their parameters for why you would begin to throw it, but probably your brass is eating into the ceramic, it's becoming weak. If you could find this as a pottery specialist, there we have a reduced exterior, oxidized interior. It's only really if you look at the outside and you can see that heavy metal fluxed vitrification of the outer surface. And also in the discard pile, we have fragments of molds from lost wax casting. And you might also find some drinking vessels in there because your artisans would get thirsty. So you could have a mixture of technical and domestic ceramics. A Bronze Age Thai crucible, which looks rather like a lamp. If it didn't have any metal traces, any slag on it, you could get that in the assigned to the wrong specialist of an excavation. And just below that is a bivalve mold for an arrowhead. Here we have some small crucibles on the front, and then 3 little metal ingots. And so the 2 back rows are actually little ingot molds. These are bivalve molds in ceramic for axes, but they could also be in other materials. You can cast in wood if you have to. It won't last very long, but you can do it. Again, Thailand, Iron Age iron smelting workshop, northeast Thailand. This is probably the exterior of the furnace, a hearth in front of the furnace. And the reason I say that is of iron smelting is a pretty hot technology, and this is a particularly hot example. We're talking 1450 here, because they were smelting laterite, which is a low-grade ore, and they needed very high temperatures. So the rest of it, again, is a molten mass here. We've got collapsed furnace wall, tuya in the center. See if I can work, yep. These are the tuyas on the outside. This is the exterior facing out the furnace, and that's the interior, which as you can see is vitrified. And actually, tuyers can often be quite long and they're consumed during the operation, and it's necessary for the system for the ceramic to be consumed. It's contributing to the slag. So this is a section of a furnace wall. Now, if a furnace isn't fully dried before it's used, and these could be quite thick, say like 20, 30 centimeters is possible, you could have the inside vitrified, then a section that's properly fired, and then the outer could not be fired at all. So in the rain, you'll lose your exterior, and you'll end up with just a small section that doesn't represent the original thickness. And again, then we just have this enormous mass of slag, tuyere, furnace wall, and it's a continuum. There's not slag and vitrified ceramic. There's a continuum flowing through, and you can't interpret one without the other. And we'll go to Laos, northwest, Luang Namta province. An ethnographer saw these two round shapes in the ground. We went and had a look at them. So we've about 50, 60 centimeters across there, just under a meter tall, a hole at the bottom to extract the slag. And it actually transpired to be seven of them in a row with 3 pairs and then a single. Then in a nearby village, it's only a few kilometers, but it took a good while to walk. Again, we have these little circular structures in the ground. Open them up, rip them open, it's another iron smelting furnace, and it's again in a pair. Now, there's absolutely no technical reason to have a pair of furnaces that side. That is a social signifier, and within the mountains in that area, there seems to be quite a common tradition. Cambodia, 8th to 19th century. Here, people were talking about slag heaps, but actually they were better called tuyere heaps, just hundreds and hundreds and hundreds of tuyers. So here we have these cigar-sized ones, which represent 19th century production. This is Angkorian, sort of 13th, 14th century production, and then the 8th century ones were actually much larger. So you could date on the site, but on the basis of the tuyers. Jharkhand, another slag heap, but just underneath the surface, you have the remnants of a little bowl furnace. I'm not sure what metal it is. Nagaland, piston bellows. He's got a little smithy here. Came back when the fire was off, and I wanted to show this one because there's actually no ceramic in the system. That's a stone tuyere, a bamboo delivery system, so there's potentially nothing there unless you've got a bit of fired earth underneath. There'd be no sign of it. So moving on to our Southeast Asian protohistory fundamentals. Obviously, the colonial name for Southeast Asia is Indochina. Now, it's not very nice to be defined, or it's not very nice for Southeast Asians to be defined by their neighbors. In gross simplification, we see the Southeast Asian Neolithic and Bronze Age as being derived from China by various mechanisms, partially migration, partially trade and exchange, and then the Iron Age and Indianized statehood, by virtue of the name, coming from South Asia. And no Southeast Asianist is going to say there's not external influence, but of course we're denying Southeast Asian agency if we just say everything's external. And of course nothing's black and white, it's a bilateral exchange, as we've seen from Professor Bellina and Dr. Favereau. So what, I've said it before, but Southeast Asia's not first at anything, but they tend to do things quite fast. The adoption and adaptation processes are quick. And so what I said, I'm not satisfied with saying, oh, this is from China, this is from India, when these entities don't exist at this period. We want to go, at least North India versus South India. How closely can we narrow it down? Because we're talking about the influence of people, so we need to know which people we're talking about. If we want to identify that influence, there's various methodologies that are going quite well, like ADNA, linguistics, archaeobotany. And of course, we need the material culture that is iconologically plastic and has archaeometric affordances. Now, I'm an archaeometallurgist, but I'm happy to say that pottery is the most important post-Neolithic material. Normally, metallurgy is like the cherry on top to get some extra information, but in Southeast Asia, it's suffering. So Dr. Favereau has presented some very good case studies. We have reasonable Neolithic data, but for example, we have no Bronze Age typologies. There's nothing that could be followed at a regional level. Iron Age is better for the maritime networks, but inland it's not so good. So metallurgy has had to stand up and go beyond what metallurgists are normally doing to providing core material culture evidence. And of course, glass is following with Dr. Dussubieux from the Iron Age, about 500 BC. So this is the interaction spheres that Professor Bellina and Dr. Favereau were talking about earlier. So this is based upon the original hardstone bead studies. She argued for the presence of limited South Asian artisans. But remember, when we're talking about communities of practice, we're not talking about the presence of artifacts. We're talking about the presence of production debris. That's what determines whether you can identify people there. And the higher the skill requirements of the technology, the more confidence you have for the transfer of the technology. If it's something I can teach you in half an hour, that's not a very good sign. If it took you 10 years to master the technique and you see the same technique, that's strong evidence. So what we're looking at is these Indian high-tin bronze bowls. Now, they were initially spotted in the 70s at Bandon Tepet in west-central Thailand. And then they've been found in a number of different areas, mostly in peninsular Thailand, coastal Cambodia, coastal Vietnam, Bali. Ooh, where else have I had them from? I've had some examples from India via Sharada Srinivasan. What's special about them is their alloy, the way they're made, and their decoration. So they tend to be bowl-formed, they have carinations, sometimes fluting, sometimes not, but they tend to have this boss in the center, which some argue is representing the sort of an omphalos from Greco-Bactrian influences. And also, yes, the design is quite particular, mixing geometric and naturalistic details, including animals and people. And Dr. Ian Glover was again suggesting that some of them have griffins, and he's again suggesting Greco-Bactrian influence. And I'm saying something different, which I'll tell you in a second. And of course, in Southeast Asia, Dr. Ian Glover was a lot older than me, so he was right and I was wrong, and I was trying to say, well, we're just talking about different things. He's talking about the decorative style, and I'm talking about the material. They can come from different places. That is coming together to define the materiality of the bowl, which is they have a deep bowl form with a pronounced central knob. They have very thin walls. They are unleaded bronze alloy with high tin, 22-24 weight percent. They have a frozen martensitic beta phase microstructure because they were hot worked, annealed, and quenched. And they include incised geometric and or naturalistic decoration. And in particular, when they were new, what the consumer would have experienced is a very golden color, much more than your normal. It's not at all like copper, which is pink, remember, pure copper. Bronze is darker, but then the high tin bronze is very gold. And they can ring. They're extremely sonorous. But they're also brittle, and sometimes things that are very breakable can also be quite precious. And we need to identify the skill in the process. So making bronze with a high tin level is actually not so hard. You just keep adding tin to the melt. Making a bowl is not so hard. I mean, I'd struggle, but I think I could learn. Making thin-walled, golden-colored, highly decorated vessels is extremely difficult, and that comes from the hot forging process. So the skill bottleneck in the production process is the hot forging. So therefore, if you wanted to identify the artisans who made the bowls, you would have to identify the hot forging process. And if you think of that as an archaeologist, if you imagine an iron smithy where the smith's beating hot iron and you see the sparks coming off, right? Those are hot particles of iron oxide. They drop on the ground, cool down, and you can find them. It's called hammer scale. Bronze doesn't do that. So you've got a stone and maybe another stone and a hearth. So you're not going to find the evidence for that stage, unfortunately. Anyway, these are some micrographs of high tin bronze bowls in section. This was done by a former master's student who's now a lecturer. I said it was a while ago. So we've got the preserved martensitic beta phase, which is showing the production process, and then we also have the correct composition with undetectable lead and 24% tin. Now, we were looking for production at Koh Sam Keo, the site that's been mentioned quite a few times for Peninsular Thailand. And one day, someone came back from site, because all the specialists were there at the same time. It was a very interesting way to work with this little vessel. And it was actually, it wasn't even crumbly, it was like a paste. It fell apart in the time we had it. And they had this distinctive nippled base to them, broken on one side, and then you can just see these coloured stainings. And what we actually thought it might be initially was a glass crucible, because there's also secondary glass production at Koh Sam Keo, but we didn't have any receptacles for the melting of that glass. And it had this weird interior, which we did sample, but wasn't the answer. Now, finally, more of these began to turn up, and they've pretty consistently got this very, very thick base, and then the nipple on the outside. So again, we just assumed they were crucibles. They look like crucibles. We think we've got high temperature production. They were also concentrated on what was called Hill 3 at Koh Sam Keo, which had the highest concentration of South Asian related material and production debris, and it's the production of debris that signifies the presence of the South Asians. So looking at this much larger fragment, technical ceramic 17, there's a full slag layer, a developed slag, with prills of not copper, but bronze. So we're not talking about copper smelting here. We're talking about bronze melting. Probably a bit of dirty copper to get the slag. Then in the molds, what we can see here in this paste, which is not particularly refractory, it wasn't a special ceramic at all, is we've got fragments across the surface of tin-rich phases, but we can see that there's no attack on the ceramic. So it's not like this vessel has been heated, it's had something poured in, but that's not going to impart enough heat to damage the ceramic. Therefore, it doesn't look like a crucible, it looks like a mold. And then we have the production evidence. There's a couple of pieces of slag and some slagged ceramic. So within the slag matrix, we're getting what we call a ghost residual here, and that is composed of near pure cassiterite. Now, obviously in the Thai Malay Peninsula, the one thing you have a great deal of is cassiterite, tin oxide. And therefore, we constructed the argument that this could be a cassiterite cementation process. So there's not copper in this area, so you could either import copper or import low tin bronze, melt it, and then you just chuck in crushed cassiterite, and that will produce a high tin bronze. And then also found separately on the surface was this little nugget which fitted by happen chance into the mold and also transpired to be an unleaded high tin bronze. So it looks like a little ingot. So we've got this from Koh Sam Keo on the Thai Malay Peninsula, but they've also been reported from Tilpi in West Bengal. And what do we see? A crucible, and this time it is a crucible and not a mold, and a high tin bronze ingot. Now this was actually sampled by me years ago and published with Pranab Chattopadhyay. So we've got this one in Tilpi, West Bengal, just the other side of the Bay of Bengal. In 2009, I went to a conference in Bangalore, organized by Sharada Srinivasan and Professor Ranganathan. And there, I bumped into Paul Craddock, who was from 500 meters down the road in London at the time. And he goes, in Dariba, Rajasthan, we also had this same system of the nippled base, which seems to be quite distinctive. I'd be happy to know if you know any other examples. So here we're talking about a zinc smelting area, and these are again crucibles. So the point I'm making is, I think we do have high tin bronze alloy production at Koh Sam Keo. The technology is earlier in India. We do not have evidence for the hot forging stage, so I'm not prepared to make like the big call of there being South Asians present on the Taimane Peninsula. And in any event, we've had like a mistranslation of the technology. We have the right alloys, and we have the right shape of technical ceramics, but their use has changed, which suggests that it's not the same group of people who have carried that technology across. Now we'll move on to the provenance research using lead isotope analysis. I'm not going to dwell on the methodology. It's a geological technique, and it was originally developed for dating rocks, dating geological events. It's a stable isotope technique, so we're not talking about radioisotopes. It's been used in archaeology since the 1960s. It comes with warnings, but it comes with warnings because it's a very well-developed methodology. So we characterize the materials, and we start off with, say, mines, but geographically separate mineralizations could have the same signature if they're at the same period in geological time, not historical time. Same point. At the same place, if you have multiple mineralizations in geological time, you might get different signatures from the same place. Many materials have lead content. It's also very mobile in groundwater. So I've tended to work with slag, which is anthropogenic. You know people have used these minerals, and it's the master material, and it collects that lead from the rest of the system. We're talking with additive technologies, like glass, but as opposed to lithics, and we can mix copper with copper, alloy, mix copper with tin, or worse, lead, because then we completely lose our copper signature, and you can recycle. And as more you mix, you're losing your original signature. And you absolutely do not use lead isotope by itself. You have to start with your typology, work through the manufacturing techniques, look at the elemental composition, or you're going to make some silly mistakes. So what I've done here is I've plotted, this is from my data set, of high tin bronzes from South and Southeast Asia. All you really need to be looking for is, do the dots cluster together, and or do they make a linear arrangement? And as we can see, they tend to form this linear arrangement here, and then also a downward trend here, and we've got a single sample from Coduminal, pronounced correctly, I hope. So we also, this is the lead 206, 204, 207, 204, and we always have to compare against the 208, 204 so that we're capturing all that isotopic variation. Now, if I plot this against the known Southeast Asian copper production systems, this is central Thailand in green triangles, northern Thailand in yellow triangles, and central Laos in red triangles. It seems to sort of touch on Laos, but it's also got this linear tendency which doesn't fit. So basically, it doesn't fit with Southeast Asia, so it's probably coming from South Asia, although we do have unknown signatures in Southeast Asia. So this is all the South Asian geological lead isotope data collated by Kilikkanal, but not actually performed by them. And this is, I'm not a geochemist, but I've learned enough over the years. This is plotting out perfectly. You've got these systems. You need lots of dots for this method. If you just have a couple of dots, it looks like nothing. But you can see you have these gradients here, and these gradients are representing natural fractionation of lead. This is according to 208, 204. But remember, we're talking about a dating technique geologically. But we have to deal with this issue of this is common lead up here, and this is highly radiogenic lead, and our y-axis is thousands of millions of years. So when you have highly radiogenic lead, it plots isochrons in the future. So it's saying that this mineral was formed in 4 billion years' time. Okay? So we can't use highly radiogenic lead. But if we concentrate on common lead, here we are seeing the dating of South Asian geology. So less, a few 100 million years ago, 1 billion years ago, and then up to 2.2 billion years ago. Now, as far as I know, the only archaeological data set for Tamil Nadu is done by Sharada Srinivasan on Chola bronzes published in 1999. Now the data, your geological data set has grown since then, but I think fundamentally she's still perfectly correct. You can see that her bronzes are plotting in this area, and this area. So I've dropped off the ones that aren't relevant. I did keep on Tamil Nadu Galinas and Karnataka Galinas to see that it's not matching there. How long? Okay, sure. And then plotted against the other axis as well. So Sharada's conclusions remain broadly correct. What I tried to do now is plot my high tin data onto the same plot. And again, it looks as though we're going in the same sort of area, but we're not accounting for this linear tendency, which we call a radiogenic tendency. So this means that the copper, at least one of the copper mineralizations, had associated uranium, which is producing this line. So again, I stripped out the unnecessary geological detail, but here's a key point. None of this geological information is any good, because these are typically on galinas. This is lead mineralizations, and we're dealing with unleaded bronze, so we actually have no idea. As far as I'm aware, there's no, well, maybe Randall Law did a little bit in the northwest for copper, but for the rest of India, there's no data. So where might this copper be coming from? So you've got your major reserves in Rajasthan, Madhya Pradesh, Sikkim, and Jharkhand. Of these, Jharkhand's Singhbum copper belt is India's single largest source, nearest to the Bay of Bengal, located near Tamralipti. Somebody's told me off previously for calling that city of copper, and at the eastern extremity of the Mauryan Empire, which seems to be transmitting Buddhism to Southeast Asia. And it's a major source of uranium. So I think we'd probably go and have a look there. So here we're on the Suvarnavika River, running up to Tatnagar, and I went there 12 years ago, believe it or not, with Dr. Prabhakar Upadhyay from Varanasi. The place is absolutely riddled with mines. That's been known from the mid-19th century. We have the uranium mine nearby, which should produce a highly radiogenic lead signature. The problem, I'll get onto, so we've got mounds of slag up in the mountains and also down by the Suvarnarika River at a site called Tarenga. And in 2013, Dr. Prabhakar had a prospection permit to sort of scrape down and have a look. And the problem we ran into was not being able to get export permits. So 12 years later, I still don't know what the isotopic signature of that slag is. But the Bay of Bengal is that way, so it seems like a logical possibility. However, I don't think it's the only possibility. We've got multiple production signatures in that high tin database. So geologists are going for your major economic copper reserves, but we could be interested in small, uneconomic ones. Geological maps, and I'm not just talking about India, I'm talking about anywhere, they can be incomplete, uncovered zones. They could be wrong. I was surprised to hear Thai geologists a couple of months ago just laughing, going, oh yeah, this one's completely wrong, we'll have to do it all again. So what Indian archaeometallurgy needs is an integrated lead isotope program using multi-collector ICP-MS, not TIMS, and covering multiple metals, and specifically to include the south. If you don't mind, I'd like to do it with you. So high tin bronze bowls. They are a media of cultural, material, and technological transmission between South and Southeast Asia. In reality, there's probably, yes, South Asian artisans performing, but I don't have the same level of evidence as Professor Bellina because I don't have that production debris. The materiality is complex, potential Hellenizing forms in the omphalos, the exotic decoration. Some people have said they have Buddhist associations like Himalayan ringing bowls, and they can be skeuomorphed in other materials. I've heard them mentioned in pottery forms, and they could also be imitating actual precious metal ones. In terms of the provenance, nearly there. High tin bronze bowl exchange network is multinodal in South and Southeast Asia. And I've also, within Southeast Asia, noticed ancient imitations. So bowls that look right, but they have the wrong alloy. They're not wrought thin walled, the decoration's wrong. The source of the copper isn't clear, but we could actually sort it out quite quickly within a few years. The source of the tin's harder, but we can attack it using tin isotopy with one particular lab in Germany. And of course, the bowls didn't move alone. I've got other unknown signatures in Iron Age Southeast Asia. So people have always talked about the Indian bowls, but why not Indian bangles, Indian earrings? We just don't know because we don't have any production signatures. And of course, they could be accompanying other materials like the glass as studied by Dr. Dussubieux, and they could be traded materials, or we could have people moving around. And there was a recent DNA paper claiming, I think it was like 2nd century AD South Asian individual in Cambodia, which is totally possible. So thank you very much. I'd just like to acknowledge Professor Rajan and Dr. Kunungo for inviting me to Chennai for the first time, and your respective institutions. Studied over 1,000 samples in the last 20 years, 130 sites, dozen countries, loads of money, but mostly the ANR in France. My 3 main teachers over the years, Cyprien Boubank, Thilo Reren, and Vincent Piggott. Professor Bellina, we finally come to India together after quite a while of talking about it, and to the catering staff for all the lovely tea and food. Thank you.
Thank you, Thomas, for that exciting presentation. I suppose the 3 papers, we have 3 extremely interesting and exciting papers on pyrotechnology from southern part of China to Thailand and from the Indus Valley. The papers are actually open for question now. We have some time for question. Please ask the questions. Yes. Yes, sir.
Just one information I would like to share with.
Use the mic.
Recently, we got height in bronze at Shastapuram, and we have done XRF analysis, and it gives 36%. And in Adichanallur, again they have done by Kalpakam, Indira Gandhi National Center for Atomic Research. They have also handheld XRF that also gives the same range. And the AMS data that has been collected by the Archaeological Survey of India in Adichanallur, where we got plenty of height in bronzes. There also the date goes to 2400 BC. Now the situation entirely changes because we don't have copper ore, but we are having plenty of height in bronzes. At Kodumanal we got, now Shastapuram, Adichanallur. So how could understand this one when comparing with Thailand?
Well, thank you very much. The data are not just Thai. So we have Indonesia, Vietnam, Cambodia, and India. So there's already one Adichanallur sample that came from Sharada Srinivasan, plus the Kodumanal. The Adichanallur plots in the same linear tendency. So it's within one of those networks. The Kodumanal looks different, but that's because there's only one dot. You need to do a lot of analyses, and then what looks like random dots will, over the years, suddenly make sense. Yeah, so if we just perform the same analyses.
Any other questions, please? Ceramic technology of the Lai people of southern China, or the stoneware technology which Massimo Vidale has actually presented. Yes, you have questions.
Yes. I had your pressure release valve reminded me of an ethnographic study I'd seen. I think it was South India. I believe it was casting of mirrors. And they, in the mold, they put a layer of muslin or something and then recovered that with ceramic, and it was stated it was to release the pressure. So I'm not saying this one's ethnographic and yours is thousands of
Thank you,
years.
very interesting.
Yeah, but it's an example of a pressure release.
I think some of these principles circulated anyhow. They were latent in many different technologies, so they could be resumed at will for some particular form of production.
With that, I have a kind of curiosity, Professor Balvally. The thing is that why do you think that there was a need to create pressure? Do you have any thoughts about that?
No, I have the evidence that pressure was created, and I am wondering about it. So this is a question I am positing to the archaeometric specialists who will investigate the behavior of that particular kind of ceramic tools and compositions. But the two vessels which were overfired were really brought to the level of cracking and exploding, so it is clear that a lot of pressure was developing inside.
It's obvious that it was creating some kind of, problems, and yet they...
It's a question which I pose. Maybe besides the temperature and chemical composition, maybe, and also pressure could have played a role in creating, such a homogeneous and pores-free ceramic structure. But it is a question.
It's true. Any other question? Students? I think there are no more questions. I would like to thank all the speakers for an excellent presentation, and thank you very much for your patience.
Hello, check.
Scholars, kindly wait for a valedictory ceremony for 10 minutes only. Then we can have a tea break.
Where is Dr. Alok? We call Dr. Alok. May I request Dr. Shivanantham? Time waste பண்ணாத. ஃபீட்பேக் வாங்கிட்டு மூணு தான் 10 minutes
Good evening, one and all present here. We thank all the dignitaries, delegates, scholars, students, and other enthusiasts for having made the 5 days international conference in commemoration of Padma Shri Airavatha Mahadevan on history, science, and technology on South Asian ceramics wonderful, informative, and energetic too. We would like to have feedbacks. First, let us have from the delegates. One person can represent others from the delegate side. Anybody? feedback, comments? Yes, sir. Welcome, sir.
First, I would like to thank all of the participants, students, all of the distinguished scholars, all of the other guests who've come here for providing such a hospitable and friendly atmosphere for discussion. This is one of the most important aspects of conferences, is to have a positive venue for interaction of ideas. Everybody's been very respectful as people presented and been very attentive and listening. So I think this has been one of the most exciting parts of this conference to me, because many times people are not so friendly. So I would really say thank you very much for being such a welcoming and considerate audience, and also for being patient as people presented. Then I would like to also thank the organizers for the foresight to pull people together from so many different parts of the world that are doing many different kinds of things. We've learned from Hainan, we've got from Southeast Asia, we have from Northeast India, we have from Northwestern Pakistan. All these different areas have come together as a part of, and even from Greece, kilns from Greece. So it's brought together a lot of different topics that normally are not found together in a conference. And I think this is one of the really exciting aspects of this conference, and I hope you'll take away the importance of sharing ideas across many boundaries. The colonial models were always having arrows going from one place to the other, and I was just discussing with Professor Bellina about we need to have arrows going in both directions all the time, because you can't have ideas going in only one direction. There are things coming back and forth. So we need to always consider the interactions around the world and not just the directionality of what things have been presented in the past. So thank you again for the organizers, and that's my comment. Thank you very much.
Thank you, sir. From the registered participants, can one person come? Anybody can come? From Madras University, Mr. Gokul.
So, good evening to one and all are gathered here. By attend the four-day session, actually the vision of archaeology, especially in the ceramic studies, was totally changed in my view, because I thought that scientific studies were very lesson focus on in my view. So hereafter, here on and all, everybody aspect on the ceramics and other related terms will be studied in the scientific manner. Like today, the microscopic studies and such terms were very strange to us. So, hereafter, we all are focused on a scientific approach on the archaeometric studies. Yeah, thank you.
Thank you, Gokul. From Tamil Nadu Institute of Archaeology and Museology, Selvi Ananya.
Good evening. I'm Ananya V. from a student studying in PG Diploma in the Institute of Archaeology and Museology, which comes under the Tamil Nadu State Department of Archaeology. Firstly, I would like to thank Dr. Alokanungo sir And I would like to thank Dr. Sivanandam sir, Dr. Rajan sir, and all of the staff of Tamil Nadu State Department of Archaeology who have worked tirelessly to make this 5-day international conference on history, science, and technology of South Asian ceramics a reality. I would also like to thank IIT Madras for providing this comfortable auditorium setup, and this international conference was a rare opportunity for students of archaeology, for archaeologists, and also for archaeology enthusiasts, for we were enlightened on various aspects related to ancient ceramics, such as glazing, significance of incised pottery, the designs, the decorations, graffiti, script on pottery, basket-made pottery, polishing, importance of oxidization, reduction, the kiln setup, torpedo jar production, burnishing, etc. We were taken on a mental tour of the Indus ceramics and seals. We were updated on the most relevant and the latest methods of scientific analysis of ceramics, including petrography. We got a good picture of the ceramic scene in the Gujarat area, and also the big picture of the ceramic production and trade in the South and Southeast Asia, including Thai Malaya region, China, Northeast India, South India, etc. The live demonstrations, am I audible? Oh, okay. The live demonstration of the Nagaland handmade pottery using paddle and anvil and the wheel-made pottery was most valuable, because that is not something that students like us can get just by reading books and sitting in classrooms. So that was most valuable. And mainly, I would like to thank all the speakers for traveling hundreds of kilometers or miles to spend time with us and share your expertise. Personally, it is quite daunting for me to think about just how much time and effort has gone into the field work, the lab work, and the brain work to produce each of these papers, not to mention the years of accumulated wisdom that is evident from your careful selection of words. As students, we aspire to be equally diligent in our work, and hopefully we'll live up to the high standards that you've all set for the field of archaeology in general, and we will be ever grateful for any guidance you would be kind enough to provide us in the future. Thank you for your patience.
Thank you, Ananya. Then Mr. Mervin from Tamil Nadu Institute of Archaeology and Museology.
Hi, one and all present here. I am Mervin from Institute of Archaeology and Museology. A warm evening for one and all present here. And I guess that everyone have enjoyed this pristine environment with the presence of monsoon, also the mind-blowing perspectives of the intellectuals. I am excited to share my view about the short travel we all made on our past in search of truth. For me, it was like coming out of an information superhighway, literally, if I say about the 3rd International Conference in commemoration of the Padma Shri awardee Airavadam Mahadevan. Standing in front of the Dolpur house and getting into the coveted civil service is a dream for every citizen of India. I could imagine his craze on archaeology, from the way he gave voluntary retirement from IAS to pursue his interest on epigraphy. And then regarding the presentation of the speakers, personally I had an eye-opening moment with Professor Rajesh Nayar's insights on marine seismology, side scan sonar, magnetic surveying, the role of oil exploration in marine archaeology, and also the various instruments used in non-destructive testing of samples like Raman spectrometer, crystallography, etc.
Also, I came to know from Dr. J.M. Kenoy's views on classifying Harappan face into 3A, 3B, and 3C. Then his gender studies with respect to pottery making was a nice one. Especially as the discipline of history and archaeology contains thousands of terminologies, I got to know some new terms like Sorat Harappans, chain operator, Solanki, the other name for Chalukyas, and then ceramic petrography, X-ray diffraction, archaeometric analysis, etc. The live pottery making workshop literally takes me to the prehistoric period. Fellow students were excited to hold the pottery, which they made jointly with the craftspersons. Trade and cultural interaction had a lasting influence on ceramic culture of India, quote unquote. The statement of Professor K. Rajan gives another perspective. I also get to know about distinct types of potteries such as terra sigillata, Hellenistic ware, etc. Personally, one of my favorite subjects was sociology. On hearing ceramic sociology from Professor Mudit Trivedi, it really excited me. And then here comes the most interesting part, the feast. The Russian salad, dahi, balla, jackfruit biryani, Gujarat halwa, and so on. The cuisines was well and good. A genuine thanks for that. I am grateful to thank each and everyone who played a pivotal role in successfully ending this conference. My special thanks to Thiru T. Uday Chandran IAS, Commissioner of Archaeology, Government of Tamil Nadu, Thiru Sivanandam Sir, Joint Director, Department of Archaeology, Government of Tamil Nadu, and Professor K. Rajan, Academic Advisor, Tamil Nadu State Department of Archaeology, and then IIT Madras, Director, Professor Kamakoti, and then Professor Alok Kumar, IIT Gandhinagar, and then all the archaeological officers and assistant archaeological officers, researchers, authors, students, and others present here, one and all. Thank you.
It's my pleasure to be standing here. And we have a certificate distribution ceremony, but looking at the large number of people, we would be only giving one certificate at this point of time, then others can collect it. And can I have one certificate for the delegates? Anything comes, who is present, that's all. Give me some. Sorry, the certificate to be given came first was Jonathan Mark, it's not possible that I would be handing over a certificate. I would rather hand over, I would request Professor, give me a junior one. Sorry, somebody. This is something I can, because she is the one who is probably is going to take the baton from me. And I invite Belina to come over, and Professor Mark Kenoyer, I would request you to hand over the certificate to Belina. Okay. And certainly to one senior who has been a father figure as well as a friend, I would say. I started my career idolizing a scholar like him, but then it ended up when we invited him to give a talk on this presentation, he's calling and saying, "Ah, look, this topic is fine or that topic is fine." Such a senior scholar and such down to earth, you never imagine. And such scholar who never speaks one line extra, one line less is Professor Ajithprasad. I would invite Massimo Vidale to hand over the certificate to Professor Ajithprasad. And one of the registered participant, I would call, I don't know who is she, but I'm calling Momi Das. Okay, she's Momi Das. I'm seeing her every day. And I would request Dr. Sidharth Shankar to hand over the certificate to her. No. And certainly to one boy also. Sarath Chandra Babu. Sarath Chandra Babu. No, he's collecting the TA. Looks like that. Sasank Babu. Oh, Sasank Babu is there. So I request Professor Rajan sir to hand over the certificate. Yeah. Gokul from Madras University. From TNSDA, may I invite B. Archaeolio, and may I request Sidharth Shankar Rai to give this certificate? Come. And Pavitra Devi. May I request Mudit Trivedi to give the certificate to Pavitra Devi? All other certificates are with our background person who has done all the hard work, Mrs. Bhakya Lakshmi. Please give a round of applause for her. And without her, this conference would not have been possible. Okay. This is something which a ceremony which I have to do, that's the vote of thanks. It's hard for me to start a vote of thanks in such a series. For the first time when this series started, this started with the blessing of my mother, and she's no more. 2 conferences I did, and in the end of the day, I will turn off and tell her everything. Today, certainly I miss her. Okay, having said that, this conference was started for 3 series. We started to start with stone, glass, and ceramic. That was our commitment. That was our declaration. And it ended up so that every time we did this conference, every 4 years started increasing by number. And what pride we take in this is scholars like Professor Jonathan Markenoer, Professor Massimo Vidale, Laure Dussubieux, Mudit Trivedi, and our own Bhuban Vikram, and of course, a sleeping scholar for last 2 conference is Belina. She all the time accepted the invitation, and this is the first time she turned up, and is lucky that she turned up with her husband too this time. So it's cover up for 1 conference. So it's very hard to maintain such scholarship, such scholars coming to your conference repeatedly and contributing and staying with all of you for a week. For them, getting a week is not only hard, but they have to value that how much do you want to learn. And certainly, sir, we are happy. All the students that did learn, and you can see from these 5 days that the TNSD students are so attentive. Their eyelids are not falling. I've never seen a student looking at the watch, though it has been the 5 days. It's not a normal case. And this credit certainly goes to Professor K. Rajan and Dr. Sivanandam, who has trained them, who has made them, who has given them awareness about this Indian heritage. If you do not have an awareness about Indian heritage, people would certainly stood looking at the watch. Yes, I was little cut by going and saying, oh, it's 45 minutes, it's 15 minutes, come on, that's my job. Please forgive me for that. But then at the same time, I was so happy to see everybody coming down and nobody is going to the market. Maybe it is because it said we are inside the campus, and what else you could see for your entertainment, you were the deers. And so you didn't have to go, and that's one plus point of doing the conference in a campus rather than in the city. So you till now I'm seeing the full audience. And then we have been contemplating with the idea that next to be a history, science, and technology of metallurgy, Indian metals. Yes. Then when that would be, we are not sure of. We have invitation from few universities, including the famous Deccan College Postgraduate Research Institute, and we have invitation from Sikkim government. We do not know, there will be much more. And this Iravata Mahadevan conference is meant for a very general public, because it is very difficult for any conference organization which is making an annual international conference to deny the people. The most problem was that we had 300 applications for participation, and we had to say no to 274 people. We only could accommodate 30, and 4 of course didn't get the ticket or didn't get the leave and couldn't come. That's a really tough job, because Rajan sir has got a credibility. He has earned a credibility for last 70 years, and he has to say no. He is the person who never says no. I have never seen him no. And of course, I had to say no, but in the below I had to write on behalf of academic conveners, and that certainly goes to Rajan sir. And Sivathan sir, he never speaks. Another thing, he never speaks, he only works. So the problem was that I was the only one who was speaking and writing, but the person who are working for this conference, the person who visualized, the person who made this conference successful are these 2 who are sitting right on the dais. Though everybody started giving a credit to me, everybody started saying thanks to Alok Karungo. It was not thanks to Alok Karungo, it was certainly thanks to Tamil Nadu State Department of Archaeology with a visionary of Sivathan sir and Rajan sir, and certainly the equal credit goes to Bhagyalakshmi madam. There is no doubt about it that she is the one who was working for it. And then we had certain issues. It's an international conference. People are coming from 30 countries, right from Siberia to Nagaland, and they are ending up in Tamil Nadu state, and Tamil Nadu government has to take the responsibility of so much of expenses too. And the commissioner has a right to ask, what is this for 5 days? As it, like anybody would ask, if you are making a marriage, what are you going to get? My daughter-in-law would be good enough. If I'm making my son's marriage or I'm making a daughter marriage, is it like my son-in-law good enough? That was something certainly was there. And just one day before Rajan sir drops in, and we decide to go to tell the commissioner, report because commissioner is busy with the industrial conclave, as you know. And we went to Honorable Commissioner to update the thing. And the best thing was possible for us, no commissioner gives you more than 10 minutes. Oh, yes, you do get fund from them, but they don't give. But he gave a time of 7:45. Then Rajan sir says, 7:45 means we will have enough respectable time. Nothing more than that. And we go there and we just say, okay, last 2 conference publications, we put it on the table. He was rather, what would you say? It's no more a commissioner, it was more of a mother. more of a saying, okay, these all are the people, I checked the delegates, this many people, we are happy. Then he said, this is the output, everything's changed. A commissioner who respects a publication, what more we can expect? Nothing we can, neither I knew him, nor he met me ever. This was the first meeting. Somebody gets, and being an IS officer, I looked at the first IS officer who looks at the content page very carefully. Very carefully, he took some 10 minutes looking at the content instead of looking at the colorful photograph, what we had in those books. Many of you must have seen this stone bead book and glass book, which is full of color plays. He looked at the content like a very much color. It's nothing. I just got back to as if I'm talking to Professor V.N. Misra or Professor K. Padaya, who would not look at the book, who is publishing, they will look at the content page. Or you go to R.S. Vist, first time they look at the content page, and the commissioner was looking at that. That changed everything. That melted all the thing what we had thought of. And today we are here, though he is not present, but he has sent us all the good wishes. He is really busy with the industrial conclave. He tried to come twice either during inauguration or during the, during a dinner time, but he just couldn't get time. But I'm sure one day or other day, we are going to have his word. And maybe with another publication, he would be, that's something we can give him, what he has done for us. And then there was another issue is we are on the 4th, on I think 2nd, RS wished us to open this conference. And on 2nd, I get we got an email saying that he has fallen ill and he wouldn't be able to come. And it was gracious enough that he sent a PPT along with that. But PPT was not enough to open a conference of this nature. And Professor Mark Kenner was excavating Aladino, and that was his first day of excavation. So, of course, everybody gets tired, but he's made of something else, so he never gets tired. God, touch wood, he remains like that. And then after a day long of his field work, and I'm waiting when you will see the WhatsApp message. And in the meantime, Professor Rajan and Sivathan sir had given us consent that we can talk to Professor Kenoyer for opening the thing. At 7:30, I see that he's looking at the WhatsApp. Then I said, sir, is it possible for you? There was somebody who didn't take a minute time. Somebody who said yes. And I think that's an earning. Nothing lesser than an earning for me. That nothing can be bigger certificate than that you take a right on some scholar who is one of the biggest scholar on the South Asian archaeology, who is in the field, he's coming from the excavation. And mind you, he reached there at about 4 o'clock in the morning and gave your inaugural lecture at 10. And all of you heard that, and there was nothing missing. This man is encyclopedia. And I have the blessing, and I'm sure he will continue to be part of this conference. And besides that, another person will be Massimo Vidale. If there is archaeology, then there is Massimo Vidale. If some of you didn't know Massimo Vidale, tomorrow you forget it, better you leave archaeology. Somebody who makes archaeology complete. Somebody who talks archaeology, leaves archaeology, and says how you should do it. Don't do and third person I will take the name of is Laure Dussubieux. When we invited her, and she said, look, I don't do glass other than glass for some year. And by that time, of course, she had already this glazeware on her table. And she said, okay, I'll do that. But the way she presented it, nobody thought that she's not from ceramic, not from glazeware. Probably she presented one of the most scientific paper what we thought of. And Mudit Trivedi, who is supposed to lead the next conference of this series, and not supposed to, he should be doing it. And I picked it up from Professor Kenoyer when I was in Wisconsin, and he was running South Asian archaeology and teaching a course on innovations. And I'm sure Mudit is going to take it from here on to an extent. And then comes Carla Sinopoli. Okay, a scholar under whom I was trained in the field of Hampi twice, and we had walked on those mound, and I write, she doesn't reply long letter. Something is better of her. Is there one-liner? Yes, I'm coming. And nothing was withdrawn. And the way she did speak about it, I never knew that Kalla Sannapuli other than the Hampi. And the way she spoke, it captivated all the scholars. All the students got so impressed that I have been hearing, sir, when will Kalla Sannapuli come again? And then I say, Kalla Sannapuli works in Karnataka next, so you should not ask me. You should ask her or ask Rajan sir. And then we have many scholars, which Professor Jain Pal, a very senior scholars. And when we are looking, Professor Rajan and me were discussing, how do we cover up Mesolithic and Neolithic in this ceramic one, because we wanted to have representative of all the period, all region, all places. Then Professor Rajan suggested K. Padhaya and Jain Pal surname, and it was nothing like we just have to write, sir, can you come for it? Many of the time it's a WhatsApp message. And all of had to fill a Google form. That is something is that nothing like that. Such big scholar didn't say me that, no, we don't want to fill the form. This is my abstract. There they differ. The senior level, they differ there. They say, okay, Google form, okay, we will also fill it up. And of course, he filled, and that's the way he came. Then I would talk about, I don't have to name Bhuvan Bikram, who is an integral part of this conference. I don't know how many of you know, or he ever said, he never said, I think, to anybody, neither to me. The first grant for this conference came when he was the director of IGRMS, and we spoke to each other, and then he said, okay, give me a printout. I gave him a printout, and he gave the committee. The first external grant came from there. It's Bhuvan Bikram, who never says what he does, but he did do that. And then we have, from Baroda, we have Grace. Where is Grace? Yeah, Grace. I go to the Gujarat State Archaeology almost every week, and maybe I would not be going there anymore because Rawatji is no more. No more in the sense, I would just move to Delhi. Delhi. But then, of course, Grace should be ready that I will, because she's little junior, to Rawatji, we used to take some time to go. To Grace, every day we can go and ask her. And when you requested Grace, can you talk on Bodnagar on your thesis? It's not yet submitted. People will get scared if you're not yet submitted. But then she comes from MS University Baroda, which is not like a closed door. MS University Baroda has a big heart. Even if you haven't submitted your thesis, you are allowed to present that. That credit goes to MS University Baroda. And we have a big representation of Baroda, MS University Baroda, other than Ajithprasad sir, is Kuldeep Bhan and MS Krishnan sir. Krishnan sir just left her, and you did see their scholarship. Kuldeep Bhan, when he speaks, it is like a classroom. Anytime, right from my student time, anything he has spoken, I must have attended about 10 lectures. All the 10 lectures are codified in my mind, and I can translate that to my students. That's the Kuldeep Bhan scholarship. And we have, of course, we have Anup Ranjan Mishra and Kaushik Gangopadhyaya, V. Selva Kumar, and they are my hostel mates. They might be senior scholars, but hostel mate, so they would remain hostel mate, and you have a right to call them at any time. And Anup Ranjan Mishra has done his contribution in ceramic, and Selva, as you know, in South India, if Selva is not there, there is no conference. And any book, you think of it without Selva, thinking of this book is also difficult, the way Rajan sir played this role for last 50 years, and I'm happy that we have a person like Selva to now take over that role of any book, any conference. He is the motivator. And in the end, we have, I didn't know Prerna Srinmal, that she could be so entertaining while giving a lecture, and I had heard of her, but I didn't know she can make the academics so popular. And certainly she has a capability to make it popular, and we really have very few scholars who are making archaeology popular, though I don't know, if someday I look at a book from you the way we look at from Kenoid sir, a book on Harappa, the line drawing thing, I would be happy to see an animated book from you someday. And we have this young scholar, Chakradhari, and Sidharth Shankar Rai. Sidharth Shankar Rai is, of course, I don't have to say Dr. Sidharth Shankar Rai. He worked with me in IIT Gandhinagar, and we have a good relation. I just had to call Sidharth, can you fill the NBP? But I never said that I was also making a paper on NBP. Sridhar said, yes, yes. Then after some time I said, I was also making a paper on NBP, and he brought in, then we talked about Ganeshwar, that there is something missing about this Ganeshwar culture, and then he suggested Chakradhari, and I'm sure Chakradhari will grow to a bigger scholar. And we have, then we had heard about Amitabh Pandey and Professor Dayalan Durasamy, who could not join us today because of his commitment with many other works, but all of you did hear him in the field. What a scholar he is. If any of you will remember in the future Mahabalipuram, you will not be able to remember Mahabalipuram without Dayalan sir. His oratory and his knowledge and his involvement was so much. If there is Mahabalipuram, then you also remember in your life, at least in my life, I will remember that there is Mahabalipuram and there is Dayalan sir. Of course, Sunil Gupta, there is nobody else on the Indian Ocean. From Indian side, okay, there are lot from Southeast Asia people, lot from France, they are working on Indian Ocean. But from Indian side, Indian Ocean Network and the ceramic, that was Sunil Gupta. And we have Balina, I have spoken enough, I don't want to add more. And with Balina, because Balina had joined this conference last time also, but we are happy that Balina's contribution was that much that this time from her institute, there are 4 representatives. And neither of them I knew. All of them were like, as soon as you write, like, we are making a ceramic conference. Are you ready? Yes, Mastangar. And like, yes. I said, there will be so many students. Yes. And getting a 45-minute slot from such senior scholars and such contributing scholars, rather, I would say, who can captivate, who can train the students, like Favereau, and we had, I think, some 3 scholars from your university. And okay, Favereau, again it's coming Favereau, okay. And then it is really a challenge for me and challenge for all of us. Then Abhijit Ambekar brought what we have Torpedo jar, what everybody are listening about Badnagar these days. Badnagar is not only because a place where Prime Minister was born, Badnagar is there because there is a city. The city is there right from 3rd century BCE till today, 2,300-year-old city. There could be earlier than that, and Abhijit Ambekar brought that, which is the city should be known for. And of course, we, along with that, with Abhijit, we had Ananya and Amal Kulkarni. Amal Kulkarni is again a colleague of mine, and on tile, Maninder Singh spoke about it. And what Mudit spoke, I don't have to speak because he only has to speak that. He brings archaeology as a whole. He talks of holistic, he talks of philosophy, he talks of archaeology to be done as if from ceramic, not as if, really, sorry. From the ceramic, you can recreate the entire archaeology, but that's his ability, that's his capacity. If at all, I always worry for after Professor Basa and Professor K. Padhya taking retirement, who would fill that space in the theoretical archaeology in India? Maybe we have one in the shape of Mudit, in the name called Mudit. And Kalyan Shekhar Chakraborty, who has been contributing on the scientific aspect, residue analysis, and we heard that. And of course, on ethnoarchaeology of Northeast India, I don't think any other conference had such fantastic lecture on Northeast India ethnography. And I'm not sure if we can make a section on that. But if you can make a section on that, in that it has to be ethnoarchaeology of Northeast potter maker, that is Ditamulu Basa. And then you also heard a very interesting lecture of today, which is given by Ekaterina. I am not able to read it properly. I'm sorry. Am I right? Ekaterina? Okay. Ekaterina, but the pottery making was so good over the Siberia, and she's talking about Taiwan. And I'm sure that can go into that Northeast and Southeast Asia relationship in that ethnoarchaeology part in pottery making. And it was really impressive. We had never seen such pottery making. And pottery making with all traditional dress. My interest, as you know, I work a little bit on glass bead, so I was looking at those headgears, the dress with a little bit of beaded dresses. And along with here, the contribution which somebody else has done is Oleg Kardes, who is sitting there. And if I'm reading it properly, though he doesn't speak English, but then he understands English. So don't start scolding. He will understand everything. And he doesn't speak English, but then his contribution on archaeology is incredible. And then we have Rajesh SB, our local scholar Rajesh SB, who himself said, what would I speak after others have spoken about Sorat Harappan or Harappan grave, but his photography and what he spoke, what we wanted. It is not that what you spoke that everybody spoke, and somebody else also spoke, told me, how would you make this 3 paper independent? I said, Rajesh will make it. I don't have to. He is capable of giving an individual contribution. And we have Peter Johansson, who spoke about consumption of practice in South Deccan mortuary ritual, that really he brought where we are. About this region also, we wanted a very good scholar. He was there. And then Professor K. Krishnan, there is nobody else than from Indian side on ceramic analysis than K. Krishnan. And I don't have to name him. Everybody named him. I was rather a bit jealous. When will I get that many time of references? Maybe not in this life. Every author said K. Krishnan analyzed for me. Wish I had a microscope only other than any other work. I would have done, I am happy. But then how much acknowledgement he gets and how much reachable he is that everybody has worked. Let it be India, let it be Northeast Indian, let it be foreigner, let it be from France. Everybody worked with him. That's called teachers. And then we have, I think, Ritvik Balvally, who lives in the city where I come from. Then he added such an interesting paper on the Indo-Roman country, on the Torpedo jar, and on the talking about the geochemical and petrography analysis, which he has inherited again from Krishnan sir and MSU. And then Rajesh Nair did open up with his what Madras, IIT Madras can do, though he is a marine oceanography person. And the lecture was, I think there could not have been better lecture than what Oliver Price ended with. A lecture which talks why should we do ceramic, how should we do ceramic. So he brought, when we started the lecture with all scholastic paper, but finally for student, it has to be how to learn. So that Oliver Price brought in. With that, it's time to say thank you. It's time to hear from Professor Rajan his comment.
Just one word I would like to say from the bottom of the heart. I would like to thank on behalf of the Tamil Nadu State Department of Archaeology and the Institute of that IIT Gandhinagar and IIT Chennai and IGMS. So for coming over here and involving in your debate and discussion and exchange your ideas. Thank you one and all. And again, we will meet in somewhere with some conference. Thank you very much.
On behalf of Tamil Nadu State Department of Archaeology, we thank everyone who were behind us for this successful event. Thank you. National Anthem.
Please stand in attention.
Janagana manahati nayaka jaya he Bharata bhakya vidata Punjab Sindhu Gujarat Maratha Dravida Utkala Banga Vindhya Himachala Yamuna Ganga Uchchala Jaladi Taranga तव शुभ नामे जाहे तव शुभ आशीष मांगे गाहे तव जय गाता जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय जय जय